we're going to go ahead and get started. And I have it. That's not good. It's dropping lots of frames. That is very bad. Okay, it's coming back. All right, we'll make it work. Okay, so this is SolidWorks. This is the blank screen that you see when you open up SolidWorks. First thing you're going to do, we're going to get started with normal stuff. Go ahead and do File, New. And this menu is actually really important because unlike Word and most things you've ever used, there are several different file types you can manipulate in SolidWorks. So the first few, you see the part, you see this thing that says assembly, and then yours will probably just have a drawing or something similar to like that. You may have like a different mode that you can go into. So you can put it into, where's the other way to do it? Oh, there's like a novice button, there we go. So that's what a lot of you may see. Same thing. The advanced option just lets you have different templates later on in the future, but we can use novice for now. Go ahead and open up a part and hit OK. All right, so you all should be seeing something that looks like this. It looks like a big blank window, and now there are a bunch of buttons, and you don't know what they do. That's a good thing. So this is the entire blank universe. If you actually click and scroll, you're actually zooming in and out of space, but there's nothing there for your like reference, so you can't actually tell that. So what we're going to do first is we're going to make a sketch. So basically, SolidWorks allows you to manipulate things in 3D, but first you have to draw things in 2D to kind of tell it where the third dimension is going to come in from. So if you click on the little sketch tab over here, and then click sketch here, you get these 3 planes. These are your 3 origin planes. So you get the front, top, and right. If you middle click, you can rotate around. You can get all over the different ones. Go ahead and click on, where do you want to go? Go ahead and click on the front plane. It should basically light up in an orange rectangle. Get really used to looking at the highlighting of different things in SolidWorks. That's how it tells you kind of what's going on, is it's going to highlight different colors and different things. The colors don't always mean something, but sometimes they do. Once you click there, you'll see it kind of pans the camera in, and now you're at this two-dimensional, you're kind of on this two-dimensional plane here. Up here are all your drawing tools. They may look a little bit different depending on how it's set up on the default computer, but they're all basically there. So this one right here is a line. You can click and drag a line out. It'll allow you to dimension it and do some other things. That little check mark tells you you're done with the tool. And then go ahead and click on it. And then to delete stuff, because it's really important, is to hit delete. Okay, so everybody get the rectangle tool, corner rectangle, and draw a box. I don't really care what the dimensions are. You don't have to make it huge or anything. We just need a box. Scroll wheel zooms, again, use it. If you end up doing SolidWorks on a laptop, you will want to start carrying a mouse with you. Not having a scroll wheel makes SolidWorks pretty much impossible to use. Okay, so we're not going to worry too much about sketch stuff. I just want to get us to where we actually have a 3D part really fast. So over here in the different tabs, we're going to click on Features, and we're going to click on Extrude Boss Base. And that's going to kind of bring it into this 3D perspective, so you can kind of start seeing depth in it a little bit. And right over here on the left is where you'll be able to actually put in how deep of a extrude you want it to be. So extruding is when you pull something out. So go ahead and type whatever number you want, doesn't really matter. 5 whatever units. We'll find out later if your guys are in inch or millimeter or whatever. Most of you should be in IPS right now. And if you click the check mark again, you should basically get a box. All right, did we get a box? What? We got a box? Everybody have a box? All right, so you've made your first part. This part is not very useful. Don't put this part on a robot. It would probably weigh a lot. Well, it actually weighs nothing right now because you haven't told it what material it's made out of. But in general, you don't want to put this part on a robot. Let me see if my system works. No. Now my system works. Okay, cool. Okay, so with this is the first 3-dimensional part. So basically that same process of going into a sketch, drawing something, and then doing some other feature on it is pretty much the workflow that you do for most everything in SolidWorks. There's a lot of advanced stuff, but for the most part, you make a sketch, you do some sort of feature on it, either an extrude or a cut, or there's revolves, there's all sorts of different things that you can manipulate it with. But that same idea, basically sketching, drawing out a shape, and then going in and actually extruding it and doing some feature task on it. What else can we do? Okay, let's go back. So let's look at the screen a little bit and kind of walk through the navigation window that you have in front of you. So the stuff that will look familiar, you have your normal file menu up here that you have in every application you guys have ever used. File, edit, view, all of those. File is just the normal stuff you always use, save, all of that. SolidWorks gives you a nice list of your most recent parts. This gets really useful when you get to larger assemblies and larger parts when you're working on like a full robot. Being able to come down here and quickly grab like the full robot or some sub-assembly of it and open it up is nice. Edit is your standard edit menu. You won't use copy and paste and stuff as much as you would like. Same with undo and redo. I've never understood exactly what SolidWorks will let you undo and what it won't, but you'll be really frustrated at some point because you're just not going to be able to undo something. And you'll have to go back and like re-edit it yourself, which is not fun, but it will happen. The view menu is really useful because on occasion you'll get this little button that says hide all types touched, and you'll be really confused why you can't see a bunch of things that you normally see. Just go to view, click this button back, and you'll be able to see it again. But it hides like all your sketches, planes, and a bunch of other stuff, and it gets really annoying. Okay. Insert lets you put in features and lets you put in a bunch of other things as well. Most of the time, the things that you would normally get from the insert bar, you'll get from this main toolbar here. You won't have to go into insert to do it, but on occasion you will. Tools menu, the number one thing you're going to use in here is all the way down at the bottom is the options button. And that has a bunch of different things you can do once you start getting into it. There's a lot of different options you can set to customize it to where it feels right for you. Things like which way scroll zoom is, all sorts of things like that you can do in the options menu. Window, if you start working with a lot of different SolidWorks windows open, you can very easily cascade them or tile them or put them on split screens and stuff so you can work on different parts at the same time. Then the help menu, most of the time I end up just Googling help. There's a ton of tutorials and things, so whatever you want to do, just put SolidWorks, whatever task you want to do, and then there's normally either a written out tutorial or a YouTube video or something on it as well. There's a bunch of little quick launch buttons that are really useful. All open, new, save, all of that is up there so you don't have to go through the menus to get to them. And this is called your command manager. On occasion you'll lose your command manager and you'll be really sad, but it's normally off somewhere on some other part of the screen. So you can drag it around, but for the most part you should leave it up at the top. You may not have the same tabs down here that I do. To change what tabs are down there, at some point if you end up needing to and you don't know where they are, if you just right click you can add different tabs to them. The ones that I have on are the ones that I normally use, but like I don't use Dim Expert all the time, so I could get rid of it if I don't want it. But you can have a bunch if you want them. But if you're missing something and you don't know why, just go ahead and right click and you can add it in there. We'll go over what the different features do in a second and things. Same with the sketch things. That's right, so that's the command manager. There's room over here for different toolbars. SolidWorks is extremely customizable. You can put all sorts of toolbars and things all over the place. So if your screen doesn't look exactly like mine, don't worry. There's lots of different ways to do it. If you can't find a command in a button somewhere, there's also this window up here. Up on the upper right is the search commands window, and that'll let you actually just type and you can search different things. So if you want to extrude something, you can type extrude and it'll come up and you can just run it right from there. Also, please feel free to interrupt me at any point to ask questions or offer up something or whatever you want. I'm not worried about any of that. Okay. To the left is your main features tree. So this carries all of the history about every part that's in SolidWorks and your full, when you start getting into big assemblies like the entire robot and stuff, all of it is outlined over on the left. You'll manipulate this a lot, almost as much as you manipulate your main window. So you can get different properties of things. This is where like you set your material. If you want to make this thing a piece of copper, you can. It'll do color and things for you as well. These little tabs up here allow you to do several different things. There's a properties one. Configurations let you set different configurations for a part. So you could have, if you built a robot that has an arm, you could have a set configuration where the arm is on the floor. You could have another one when the arm is up, and you would be able to switch back and forth through them really easily. And a whole appearance tab allows you to put like decals on things and all sorts of interesting things, but not necessarily useful things. All right. Down along the bottom here, there are several tabs. There's only just two, model and motion study. But if you start doing simulations and a few other things, you'll get new tabs here that are like basically change your window. So they may be selected down here. Namely, if you're doing like SolidWorks is a pretty powerful program. It'll let you do what's called finite element analysis, where you actually break up all the parts into small nodes and analyze the forces acting on them. If you've ever seen those pictures that have like the green through red and all the parts of all the different colors and they're kind of bending, that's finite element analysis. You can do that using the simulation tool, which is in one of the Office products thing, and you can click on it and you can get simulation and stuff like that. And it'll pop up new tabs and there's all sorts of new things you can do. But again, that's more advanced stuff. There's a lot of different things in here. You can render out pretty pictures. If you've seen those on like Chief Delphi and stuff, people use Photo View 360 to do that. Okay, I think that's the main walkthrough through the interface at least. So let's go ahead and look at sketching a little bit more in detail. So let's make a new part again. Let's create a sketch on the front plane again. So now we're left with this sketch. What's the best thing? So we already saw what extrude does. So extrude is going to just pull something out in a single dimension. So if you have a square, it's going to make it a rectangle, that kind of thing. Let's take and draw a square again, but this time we're going to do a different feature on it. We'll actually make it a rectangle or a square. It doesn't really matter. And then instead of hitting extrude boss base, we're going to hit revolved boss base. This property manager over here is going to ask you for a few different things. One of the nice things about SolidWorks is if you hover over something, a lot of times it'll give you the tooltip you need to figure out what you're supposed to click on, because it's not always 100% obvious. In this case, it says axis of revolution. So you click in that window, and then you click over on one of the long sides of your rectangle. Then it'll kind of give you a preview of what it's going to do. So it's going to actually revolve the entire thing. So now we drew a rectangle, but we made it into a cylinder. So you can do this a lot with a lot of different parts that you would normally like turn down on a lathe or something. You can make a revolved part this way. So you could have different diameters going through the entire length of it. You can do a lot of different things to allow you to do that. Okay. Okay, so that's the revolve, and we know how extrude works. So we can also go back and we can undo. Let me bring this back. Okay, so if you undo, oh, there's an arrow up over here. Yep, that's undo. We can start looking at a couple of the different things we can do in Sketch. So we can delete the rectangle. We don't need that anymore. So if you select, oh, actually, something we can start with. Because I actually, in terms of like not knowing how to do SolidWorks, I didn't realize this was important for a very long time, but this is actually really, really useful. So listen up. So depending on which way you actually click and drag, it selects parts differently. So if I start here in the upper left and I drag across, it'll only actually select things that are entirely contained in my rectangle. So when I select here, it only selects this far side. If I click over here on the far right and I click and drag, it gives me a different color box. It gives me a green box, and it actually selects everything that's partial. So it'll actually select all three things. So it ends up being really useful if you, depending on if you're dragging left or right, depending on how you want to do selection. So if you only want one side of this, it's far easier to drag from it from the right and grab the whole thing than from the left, where you might get 2 lines instead. While we're talking about selection, as soon as you select something, it tells you what the selected properties are over, or the selected items are over here. It calls them entities, whatever, the selected stuff. You can add different relations to them. So right now they're not really defined in any way, so you could end up doing strange things with them. But if you tell it that if you select 2 lines like that, and then you tell it that they're perpendicular, they'll be perpendicular forever, no matter what dimensions you set to them and things. You could set them to be equal, and then they'll shrink to size. Now you have perpendicular and 2 sides equal, so you're forced it to be a square. And then from then on, no matter what you do over here, it's always going to be a square. You might be able to make it bigger or smaller, but because you've forced relations on it, it's always going to be a square. Clicking on any of those lines will let you go back in, and you can see the different relations that you've set in, so you can delete them. So if you no longer want it to be equal, you can delete it. And then when you go back through, you can stretch, and now you can make it a rectangle again. Let's see. The other thing inside of properties, as we're looking down this list, there's a button that says For Construction. This will become your best friend. So what For Construction does is it basically tells the feature part of it, so like the extrude and everything, to ignore that line. So that's just for you when you're sketching to be able to use it to add relations. So you can draw, so say you wanted a center line that went across here because you wanted to put a circle in the center of this rectangle. You could draw a line like that. If you're in a tool and you want to get out of it, like the line tool will let you keep going, hit escape, and it'll leave the line and it'll let you get back into it. If you click on this and you make this For Construction, now that line basically doesn't exist to the feature tool. So if I try to extrude, it'll still let me. But if I were to not have that construction and I tried to extrude, it would make me select which one of those. But I can put it back on as For Construction, and then it won't see that as part of the feature anymore. So now I can't select, I only have one object there now. So then if I wanted to transcribe a circle into it, now I have this center line, I know that it's centered this way. SolidWorks is really useful and tells me that it has like a little click to center right there. So then I can put a circle in, here. And then if you want to extrude something with a circle, because that's a whole closed face, it knows that the circle's there, and basically won't let you extrude it. However, if you come back down to selected contours, you can tell it to grab everything if you want, or you can select which parts of it to extrude and things like that as well. But by default, it's pretty smart to know that you want to extrude a shape like this. Okay. Let's see, other tools that are going to be really useful inside of SolidWorks. So as we move over, this Trim Entities button allows you to cut different lines without basically deleting the entire object. So if you click Trim Entities, make sure it's on Power Trim. That's the one I use the most often. You can go through, and there's several different other ways that you can trim things as well. But Power Trim basically lets you use your cursor as kind of a razor blade to slice right through the lines. So it'll basically cut lines where there's 2 points. So now that we drew that circle in here, we can come through and we can cut it, and the rest of the line stays, but only the part that we cut goes away. So if you want to get rid of the half circle, if you want to get rid of that one, now we have just a half circle here. We can go back through and cut any other line we wanted to if we need to. If you end up cutting a line you don't like, go back to the line tool and just fill it back in as soon as I actually select the line tool. Other useful things. Spacebar lets you flip your view around. It brings up this view cube. So if you hit the space bar, you can get to several different views. So if you're in a part and you want to go to the left, right, whatever, you can come up here and then you can just click on it and it'll bring you back to whatever face you want to be on. Let's see, what else do we need to work on? Okay. All right, we'll go through most of the other tools. All right, so if we go ahead and delete everything, get back to a blank canvas, let's look at what some of the other tools are. Oh, and another thing we didn't actually look at. So rectangle, by default, it gives you the two-corner one that we were drawing. The little drop-down arrow lets you draw several other ways to draw rectangles depending on what you're trying to do. So sometimes it may be better to have a rectangle that you start with the center point, then you draw out a corner, three-point rectangles, all sorts of things like that, parallelograms. If for some reason you need to do that, that's the way to do it. Most of the time you can get by, 99% of the time you can use the two-point rectangle and never have to worry about it, but it is there if you need it. We saw what...
Yes. Audio on the stream.
Oh, I do?
Yeah.
Okay, good. Thank you very much. Okay, all right, so a couple other things we haven't seen. So we saw circle, we saw line, and we saw rectangle. Straight slot basically just does two circles, but it connects them together with a line, so you tell it how big the slot's going to be, and then you can give it a diameter out this way. So you can very quickly draw a slot. Circle we did. Arc, there's a couple different ways to draw an arc. Center point arc works just fine for most things. And then you can draw around and get whatever arc you want to draw. This is one where you will often select a different one, because three-point arc is also very useful, where you give it a line and then you tell it what the radius is afterwards. So drawing half circles and things gets really easy with that. Okay. Polygon tool, similar to what you would use in like Inkscape or any other graphics program. You can draw polygons, you can make a triangle, a hexagon, whatever shapes you need, it'll do it for you. Let's see. Yeah, you can tell it what type of circle to draw it in, which will basically let you determine what the dimensions are, which are nice, whether you want point to point or side to side, things like that. Okay. Splines get a little weird, but they are useful on occasion. Basically, it's the same type of spline tool if you've ever used a graphics program. It's that same type of thing. These are really end up being very difficult shapes to machine on a robot. But if for some reason you need to make a, Pringle chip for some reason, you can. Ellipse as well, basic drawing of an ellipse. You get to basically draw the circle and then tell it how to skew it. A lot of these you end up not needing too often. For the most part, I stay pretty in the line, circle, rectangle area for most of what I do in the world, because circles let you drill square hole or drill round holes, and squares are what most people sheet material comes out of. Won't talk too much about sketch fillet because there's a better way to do it after you've made the part. You can use the fillet feature to do it. But if we do need to sketch fillet, if you click on it, you can set the radius to something like 1/4 inch. And then when you come over a corner, maybe, what's happening? Oh, it's just really small. I'm just drawing way bigger than I thought. Okay, there we go. It'll cut the corner and make it round for you, which can be very useful, especially when you don't want to cut people when you're building robot parts. Okay, so... all right, a couple other things that are nice as well. If we draw a circle and we draw a line next to said circle, so as you're drawing and sketching things, you'll notice SolidWorks does nice things for snap. So as you're moving around, it'll snap a little yellow bar down next to your cursor. That tells you that you're perpendicular, that tells you that you're vertical. Then you can escape and get rid of it. If we come over to mirror entities, it does exactly like you would expect it to do. You can select the circle, select what to mirror about, and then it'll give you one mirrored exactly on the other side of that. Again, really useful for making a lot of different robot parts. Just saves a lot of time in sketching, so you don't have to sketch every single one if you're able to use the mirror tool really quickly. Where's the mirror tool? It should be next to linear sketch, somewhere up over here. It may be hidden in yours. They do that sometimes. Do people find it? Okay. Okay. On that same note, you can also use the linear sketch pattern tool to go about sketching. So you want to select entities to pattern down here, and it'll sketch whole patterns and things for you. So like all of those nice pretty sheet metal robots that have all the crazy numbers of holes in them, that's all from being able to do things like this. What? Wow, I'm drawing in way too large of scale. Okay, 10" on circle. Nope. All right, 100" on circle. There we go. Okay, so you can see that you get nice long chains of holes like you would. One of the tricky things that I've had professional engineers who use SolidWorks every day not know, once you do a patterned entity and you want to go back and edit it, it can be a little confusing to get to. So if you click on one of the patterned parts and you come over to this thing that has the, what we called relations, where you had perpendicular and things like that, you can right click and go to edit pattern, and then it brings you back to this and you can edit it. You can drop it back down to 2 and it'll basically fix where your parts are and things like that. A lot of times being able to come in here and right click on things helps a lot. Same with the mirrored part doesn't let you do that, which it should, but it doesn't, which is kind of annoying. So once you mirror something, I don't know if there's a way to edit it inside of a sketch mirror. You can delete the relation and tell it it's no longer symmetric, but there's no way to just change what is being mirrored. Yeah, so at different times in your CADing career, SolidWorks will pop up many warning windows. Oftentimes you'll have no clue what they mean. Read them. If you need to, copy down the text or screenshot it and paste it into Google, and it'll tell you at least closer to what it's trying to warn you about. It can use some language that's not always obvious at first glance at all. Okay, I think that gets us through. The other one we can do is on this drop down for linear sketch pattern, there's circular sketch pattern. So if you want to do a circular sketch pattern around that point, you can, and now it makes a circle of lines. So that can be useful on a couple different areas. Okay. How am I going to start breaking stuff? Okay, let's build. Okay, actually, if we still have our box open, or if we can just build another box, your choice. Either way, it should be pretty fast. We can go back into features and we can see a couple more things that this has on here that we can do once we have a full feature set. Let me know when you're back to having a box, or if you need help getting back to having a box. Ian, are you making a box? Okay, you have. Wow. Ian, how big did you make your box? Oh, actually, what am I talking about? Get back into Sketch. I forgot the most important thing about sketching. That's not good. All right. Thank you for saying 3847 inches. Okay, so we've just been randomly sketching things, which is fun, except doesn't actually help you make real-world parts. There's a really important button here called Smart Dimension. This is how you actually tell what units to actually make things. Everything we did, most of the time I would sketch something and then immediately click Smart Dimension and tell it what size to actually make it. So when you click the Smart Dimension tool, you can click any of the lines, drag out, and you can tell it how big it is. So if I only want this to be 2 inches wide by 4 inches tall, I can do that. And now you can change the dimensions pretty quickly. So you can do that with all things. If you draw a circle, you can then dimension that circle. One of the options you can set up is to where you can input dimensions as you go. So as I'm drawing this circle, it gives me a little box that I can type into, and then I can just hit 3 enter, and now that circle's fully dimensioned, and I don't have to do Smart Dimension on it every time. So it's normally the default option, but it's not always. If not, don't worry too much about it for right now. We can change that setting later. Let's see, what else did we not talk about? When you are sketching, if you drag a part around, it'll snap to different points. So if you want to put something on the corner, or if you want to move it differently, you can. It'll try to give you center lines. These little dash lines that it drags out will show that you're centered with that rectangle. So you can drop it in the center really easily. Again, if you click on 2 different things, you can make relations between them, so we can tell them that this circle and this line are tangent. And then when we move it, we can't move it too far, or the box comes with us now. Okay. That's actually a good one too. I missed all sorts of things in Sketch. Okay. This box right here is just saying when you delete it, you're also going to delete the dimension associated with it. Yes, that's fine. We don't need the circle, so we're happy. Another handy button, especially when you're making things like thin wall tubing, which a ton of robots are made out of if you're just going to make a piece of extruded aluminum square tubing, is this Offset Entities button. If you click on it and then select the square, we can tell it to put in a 0.125 wall, and now we have a rectangle that has a wall thickness, and it'll be 0.125 all the way around. So if we had an 1/8 inch thick tube that was 2 by 4, we could very easily do that. And then if we wanted to make it actually apart, when we go to extrude it, we could tell it we wanted 8 feet of it, and it would do that. So now we have a nice big 2 by 4 piece of whatever. We can then set its material if we want. You can come in here and tell it whatever it is, which would be 6063 maybe, why not? And now it has, now this is actually basically a full part. You could go to Home Depot and buy this. Well, maybe not 2 by 4, it's a little big. You could go to some metal distributor and buy this. And this would be basically the exact same part you would get from them. What? I had something else I wanted to go over. Oh, right. The measure tool. This will also be one of the places you click a lot. It's one of the only buttons in Evaluate that I use very often. So in the Evaluate tab, there's a Measure button, and that gives you a tape measure that you can use anywhere in SolidWorks. So if you open up somebody else's part, like if you download a CAD file from, like you can download all of the Simbots old robots. You could download their robots and you could start measuring different things and checking how big things were. It brings up this little window, and if you click on different lines or faces, you can actually see how long something is. And it'll show you out here that this is in fact 96 inches. So it's 8 feet, like I made it out to be. But you can also check things like, are things perpendicular? So it'll say those 2 items are perpendicular to each other, which can be really useful, because often you might have something that looks perpendicular or looks parallel, but then it's actually not, and then when you go to make it, it would be really bad. So being able to check with the measure tool and actually seeing that, yes, this is truly perpendicular, is pretty useful. It'll give you things you don't need also, like total area of everything you select. If you want to know the full area of this part, it'll give it to you. Again, probably don't need that, but there may be a time when you do. What else? Next to that is mass properties. So this is how everybody, if you CAD your full robot, you can get a pretty accurate description of how much you think it's going to weigh. So this 8-pound huge piece of aluminum weighs 13.5 pounds almost. And it's pretty good on density. So it's basically using the material density, figuring out the total volume of the actual material there, and does the calculation. When we start doing assemblies and things, and you see when you have you put in a motor or something, you're gonna have to tell it how much that weighs, because it's not gonna know based on the density of how much one of the sims weighs and things like that. But once you put in those things, it'll add it all up for you, and you can get a pretty reasonable account of what your robot looks like, or what your weight of your robot's gonna be, so you don't have to guess, and you won't be wrong when you actually get to competition. Okay. All right, so now that we've sketched, it doesn't really matter where you do this, if you have just a plain rectangle or if you have something like I have, it doesn't really matter. But if you right-click on one of those faces, it'll bring up your full right-click menu, which is where you can also start getting acquainted with as well. So SolidWorks likes to prevent you from having to move your mouse all the way to the top sometimes, so it gives you kind of suggested items here. So you can hide and show it, so if you want it to go away, you can hide it, now it's gone. Then you have to come back over here and hit the glasses again to show it. You can edit feature and edit sketch. So if you want to quickly change the dimensions, it'll let you edit the sketch, and then you can actually just very quickly do something like that. And then when you exit sketch, it'll auto-update. Did I actually change anything? I don't actually know that I changed anything. I didn't change anything. Let's actually make that number different. There we go. So now I have a 3x4 tube all by just changing that little dimension. You notice the extrusion stayed the same, so it basically it was able to figure out that all I did was change that dimension, and was able to interpolate that I still wanted it to be extruded the same way into the same length and everything. So you can go back into parts and edit the sketch if you need to, the same way, and then you can make different things basically. If for some reason you got it off the first time, you don't have to redo everything. You can go ahead and edit it. What are the last couple things you need to know before you can make parts? Oh, right. So we've only done one feature on any one part. So we've made a cube, we made the cylinder, we did things like that. But most parts aren't that simple. So very rarely, besides for like a raw material, you're going to have something that's just one extrusion or one revolve or things like that. So you have to start putting multiple features. To do that, you have to add sketches. So there's a couple different ways to do that. You can right-click and click on the sketch button there. You can also go up to sketch here, click on the sketch button there, and then click the face you want to make a sketch. So if you want to click on the side or something like that, now we have basically the same sketch interface we had before, except now we're actually doing it on the side of the part. So if we come in and draw, if we grab the half line, we can drag out and we'll see those little dotted blue lines so we know we're halfway through it. We can put a 1/4-inch hole there, and then we can tell it how far away from the wall it is if we want. We can say it's 1 inch away from the wall. And then with that, we can actually use this extrude cut button instead of the extrude base back in our features menu. So we have a couple more things open to us. Now that we're actually on a part, we can do cuts. So we have revolved cut and we have extrude cut. We don't have anything to revolve right now, so we're just going to extrude it. And the default is blind and 8 feet. So it's going to drill an 8-foot hole through, if there was anything back there, it would go right on through it. The preview basically shows you where you're at. So if you only wanted to do one face, you could change this to something that's less than the whole tube size, so like 0.5 inches, and now it's only going to cut through part of it. Where are we at? We have a question? Question?
How do you do that?
I'll go back. Okay, so let me get out of here. Okay, so if you're on the side of a part somewhere, you can either right-click and hit Sketch with a little sketch button right there, or you can click on it and hit the sketch button up in the top too.
What sketch button? Do you mean the 3D sketch on plane?
Nope. Are you in? Are you on the sketch tab in the command manager?
Yeah.
So on the far left, there should be a button that says Sketch.
Yeah.
Okay, so if you click that Sketch button, then you can click on a face, and it'll bring you into sketching on the side of a face.
It didn't do that for me.
Let me see
All
what
it did was turn brown.
Oh, you're already in the sketch.
Then why?
Okay. Okay, now we're going to do a regular sketch. Now you should be good to draw anything. Okay, now you're happy. Yeah, I'll go over that as well. So one of the ways to get out of, if you get into a weird feature set, on occasion, SolidWorks will put the exits over here. So kind of near the top right of your screen, there's an X and there's a back. So this is the exit. This is one of the exit sketch buttons. It does the exact same thing as this exit sketch button does. It does the exact same thing as right-clicking and exiting the sketch does. There's a lot of different. One of the kind of weird things in SolidWorks is there are numerous ways to do the exact same thing. So a lot of it is just finding personal preference and what your mouse happens to be closest to at the time, or what you remember lets you do what you want to do. So if you find yourself in some weird thing, it may be just over here hitting the X will cancel whatever you're doing. Let me get back to where I was. So I put a line in the middle. I made a 1/4 inch hole. We smart dimensioned it from this rail to 1 inch. And then we did a check mark. And then we're going to come back over into features and we're going to do extrude cut. Okay, so it defaults again to that 96-inch thing. And we can tell it different dimensions, like I said before. But the other thing we can do is here it shows that it's a blind cut, which basically means it's not in relation to anything. It's just going to go straight off of a distance. It's completely blind, not referencing anything. It doesn't really care. But you don't have to do that. You can do others. So you can do through all, which will cut through whatever is in the part behind it. That's really useful if you just say, I'm drilling a hole all the way through it, I don't really care. You select through all, and then even if you change the shape, or if you change the shape of it later, it'll still drill all the way through whatever the part is. Then you get things like up to next, up to vertex, and up to surface. And those basically select different distances based on what's being cut out behind the part. So up to next gets the next surface, so it'll just cut through this one wall because that's the next thing. Up to vertex allows me to actually select a point somewhere in the part, and it'll cut through to that. So in a more complex part, that might be useful. Up to surface, I'm able to select an actual surface, so like a face of the part, instead of just like a line on the part, and it'll cut up to that line. Offset from surface gets a little weird. Some of the other ones you don't use all that often. For the most part, you'll stay with blind, through all, up to next, kind of those type of things. There's also a through both. If you're sketching in the middle of a part, it'll basically be able to drill out both sides of the part, which can be useful. But that's not selected here because I'm on this side of the part right now. Right, so we go ahead and just cut one of those holes through. Doesn't really matter how you do it, as long as you get a hole. Does everybody have a hole in some part? All right, where are we? All right, we're gonna go back and start again and walk people through it. All right, so repetition helps everybody learn. Part new, you can click over on sketch and tell it to, we're gonna hit the sketch button. That's how we create sketches on the front plane. We can make a 2D rectangle again. We can go to Features and Extrude Boss, and we can tell it whatever size we want. And when we check, we're back to having a rectangle. We're having a rectangular prism. Thank you. No, it was a good catch. We can sketch again on the face of the part. We can draw whatever circle we want. Doesn't really matter if it's dimensioned right now, it can be. And then we can cut through it, and it'll basically do, if we do blind, it'll do it. If we do through all, it'll do it. And then it'll cut that hole. Yes?
So if you're like in sketch mode and you just draw like two random shapes, how can you figure out how far apart they are?
How can you figure out how far apart they are?
Yeah.
All right, let me get back into a sketch real fast. So if we have a second circle, and we use that Smart Dimension tool again, you can define the different distances. So if we say those are 0.5 apart, and then I can say that this one is, oops, that was off. 1 second. So I can say this first one is 1 inch from the wall, except that was not as much useful as it should have been. And this one, it has these nice little line things, so it'll tell you that they're on the same line. And then you can set this one to be 1 inch away from that one. Then if you would like, you can set different dimensions on them with the Smart Dimension tool. So if we're making a couple different 1/4 inch circles that are all 1 inch apart, we can do that. So one of the things is, since we didn't fully define this thing though, we only told it a distance apart of these two circles. So now I can kind of drag and I get some weird stuff that I don't necessarily want. So to fix that, we're going to use that For Construction button that I showed you earlier. We can draw a center line across the front of this thing, or something close to that. If you miss center, if you hit horizontal, it'll get it back pretty close. Then we're going to tell it that it's For Construction again. And we can do things like tell it that the point here in this circle, we can click on it. We can hit the Control key and select the line again. So now we have both of those selected. We have the line and that point. And we can tell them that they're coincident. And that'll basically put that point on the line. If we do that again for this one, if we select the different point and select that line and we tell them they're coincident, we now end up with both of them on the line, and we know that they're both horizontal. We know they're both 1 inch apart. And since I was editing the feature that I had already created that had that cut, when I exit the cut, if I can click the buttons properly, it will give me 2 holes now because it auto-selected that I wanted both holes cut. If I didn't want to cut the second hole for some reason, I could go back in and I could right-click and do Edit Feature, and that'll let me come down here into Selected Contours, and I can deselect things and select only half of things or whatever else you want to do. But I actually do want to have those cut. Well, actually, let me delete that other circle, because I don't have a big enough block to do what I wanted to do. Well, I'll do it on the other one. Okay. When you minimize SOLIDWORKS parts, it's probably one of the most annoying features of this entire application is it decides to put them down here without any names whatsoever for the most part at most resolutions. So you kind of just have to guess. If Windows is working well, when you click down here, you'll actually be able to get the part names up. That doesn't always happen. Okay, so a couple of things to look at when you actually have a feature and you have another entity on it, like a cut hole. So again, like I said, there's a lot of different ways to do the same thing. So we saw earlier that you can do a linear pattern of holes. If you sat there and you wanted to make in the sketch mode, you could make a pattern of holes going all the way down apart, and you could cut all of those out. The other way to do it is you can cut a single hole, and then you can do a linear pattern feature and tell it what direction to go. So this direction tool right now is blank, but if you tell it what direction to go, and then you can give it a distance, you can tell it how many. We can do whatever, 95 of them. And that'll put holes all the way down my 8-foot long piece of stuff. And I can hit just done, and now I have a ton of holes, and I did that much faster than sketching every one of them, possibly even than just doing the linear sketch stuff, because you have to deal with a much bigger sketch that way. Couple things. So this happens pretty regularly. I lost my part. I don't know where it went. You will at some point lose your part in SolidWorks. You'll be sad for a little while, then you remember the fancy button up here. So this is one of your view buttons, and this is zoom to fit. If you click the zoom to fit button, it brings everything back, which is very happy, because otherwise your part's gone, and that's sad. Some days you'll lose your part because you end up having, if you end up with 2 parts in an assembly or something that are really, really far away from each other to where they're so small that even when you zoom to fit, they still can't be seen, that's just not fun. There's ways to deal with it, but it's less than pleasant. We'll probably get there at some point this weekend, because it happens to everybody at some point. We didn't really talk about this view bar very much at all. So we started with the zoom to fit button that brings everything that's in your whole universe, basically, whatever that part universe is, into view. The zoom to area allows you to drag and click, and then it'll zoom in on just that area. Previous view lets you switch between different views if you want to back up and go to different ones. We'll deal with section view later. That's where you can kind of make the fancy cross sections of different parts and things, but we don't really need to do that while we're just doing modeling stuff right now. View orientation is the same thing that the spacebar does, if you have it set to use the view selector. This guy just kind of lets you see different ways that the part can be viewed. So you can have one that has the lines, you can have one that doesn't. Taking off the actual outlines of the parts give you a bit more realistic look for the part, because things in real life don't have outlined edges. But you can also make wireframes and things as well that sometimes gives you a little bit better view of what you're trying to do on a part. So all up here, right along underneath the command manager, there's a bunch of different view buttons. It'd be nice if there was a way to make this bigger on the TVs, but I don't know how to do that. No, that's not going to happen. All right. Okay, display state. This hide show items button is actually the same stuff you get from the view menu, and I've always just done it from over here when I click view instead of clicking on it here, because then I have to remember what all these symbols mean, and I don't remember what half these symbols mean ever, because they're tiny and small. It hovers over and lets you see them, but if it works for you, feel free to use it. I never really do. Same with this guy. This brings up the full appearance manager. So if you want to make pretty colored parts, you can. Same with this is how you change backgrounds. So if you want to get really fancy and make weird backgrounds for your part as well, you can. Except I clicked on the same one we were already running. Sometimes. Why is it not letting me? Apparently it doesn't want to let me have backgrounds today. Alright, whatever. Normally that would let you set backgrounds. The backgrounds aren't really that useful. Sometimes it's useful if you don't have, if you can't see something because the background's not letting you. Depending on your computer, you'll have different view settings here that you can basically make your parts look nicer. You can add shadows. Ambient occlusion basically simulates light, so it'll add shadows on different parts of the part, so it makes it a lot more realistic. Perspective changes your view. Can't really see it with just a bar, but it puts it into perspective view, so you get it like it's almost like a sketch. Okay, let me get it back to not being purple. So if you ever want to clear an appearance, is what like the different colors and stuff are called. If you right click on whatever the part is, there's a little balloon here. And if you click on the X next to whatever the color is, it goes away and it gets back to its default. What's the other useful one? Okay, so the other really useful feature that we'll use a lot is called fillet. So we had sketch fillets before, but now we can select many different edges on a three-dimensional part, and you can tell them all to be the same dimension. You can select whole faces, and it'll select all sides of it if you want to, and you can make nice rounded corner bits, especially on parts that are going to be sanded and things like that. You don't want to cut people. On a piece of extrusion, probably not necessary, but on parts that you actually make, you definitely want to put fillets and nice round corners and things in. Okay. Alright, so that was about an hour. Good. Okay. Okay, so that was fast, somewhat intentionally, because it's just to give you an idea of what you can kind of do with the sketch and feature tools. So basically the buttons that I went over in that hour are pretty much what I hit and use for most everything that you do. There's some other stuff when we start getting into assemblies and stuff, but for just part generation, that little bit will get you 90% of the way through SolidWorks. If you do that in different patterns and orders and things, you can make close to every part. Let's see, what can we do? All right, so I want to make sure that everyone's kind of close. So I'm not going to do this one on here. So what I want everybody to make, this is not whiteboardy. What can we do? I can make, what? That's way too far away. I'm far too tired for that. Hey, programming camp. Okay. 1 inch round tube with 1/16 inch diameter wall. All right. So, and make it 3 feet long. Okay. So outer dimensions of the round tube would be 1 inch. The wall thickness, so how thick it would be 1/16 inch, and I want it 3 feet long. So you can work with other people, figure out however you want to do it, but I'm not going to do it, and I want to see if you guys can get there. So you can do it, make a new part first probably, or do it from the same part. I don't really care. You don't need to have any of these for later. Anything that we've made so far you can regenerate pretty quickly. Also, it's a good time for questions. Oh, let me put the instructions back. All right. Okay, so to pan across the screen, if you have a mouse wheel, the easiest way, it's somewhat unintuitive, but the way that most people do in SolidWorks, just because it's faster than having to hit the keyboard, is you zoom out a little bit, and then if you move your cursor and zoom back in, it'll zoom back into it'll zoom back in around your cursor. So that's the way that most people do it if you just want to use your right hand. If you really do need to pan for some reason, I'm going to make a guess here because I don't remember, but it's either Control or Alt or one of these, and middle click. It's Control. I'm so good I got it on the first try. Control middle click will actually let you pan the part around.
What if you want to rotate it?
Which way? Like just like full spin? Middle click by itself will let you do like the full spin.
Awesome.
If you need to do, there's some other cool ones. If you do Alt arrow key, yeah, Alt arrow key will turn it in like clockwise or counterclockwise. So like Alt left or Alt right on the arrow keys. So you want to move it like a face. But if you do Control, you can pan up and down with the arrow keys too. Shift gets you to different. Will actually rotate you. Will rotate you basically around a cube. If this is the face, if this is like a front face of a cube, if you do the Shift arrow keys, it'll rotate you around the cube.
Dude, what the heck is this supposed to be?
Yeah. See that's what. Yeah, the weird settings and things are very odd. They will get you to really weird places. That's weird. Why is it doing that again? Oh well. Okay. Most everybody have a tube? Anybody not have a tube? Anybody have any questions about a tube? Did people verify their tube dimensions? Are they actually accurate?
No.
Did you use the measure tool? Or did you do it some other way? Question mark. Use the measure tool.
I made it look like it was 15, 16 inches.
Yeah, look, my pipe's in a factory.
Okay, so just so you can put your pipe in a factory, that's true. All right, so to show you how I would do this, just so you can see kind of how fast it can be. If we do new part, we bring over to sketch, front plane, circle, you can click an inch, offset entities, reverse. Wait, did you say you made a 15th, 16th circle? Ian? What's your wall thickness on a 15th inside dimension tube with an inch outside?
Oh.
This is why you measure things, because your tube is wrong. You have a 32nd inch wall tube. A couple things I did not talk about and ways that you can make SolidWorks go a lot faster for you. So if you're doing things like tubes, the offset entities tool that we used before helps you out. But if I want 1/16 of an inch and I don't feel like figuring out what 1/16 of an inch is in my head because I happen to not remember, SolidWorks is awesome and does math for you. So if you do 1 divided by 16 and then click tab, it does it for you. SolidWorks is even more cool. If you have something over here and you want to add a 30-second to it, you can do plus 1/32 and hit tab, and it does that for you too. So in any of these little like dimension boxes, you can do full-on plus, minus, divide, multiply equations, all you want. It'll do reasonable unit conversions for you. So if I wanted a 4mm wall inch tube for some reason, I could type it, put it in millimeter, and it'll convert the inch conversion for me. It'll do reasonable ones. It doesn't do all unit conversions. You can't do, there'll be some later places where like it'll ask you for, like if you're using simulation tool and stuff and it's asking you for pound force, if you want like force in pounds, you can't put in newtons, it won't do the conversion for you, so you have to Google it. But for the most part in like all the normal 2D stuff, you can put in whatever dimensions you want. You could put, well, it would break if I tried to do that, but you can put in feet and inches and it'll add it all up for you. It becomes really, really useful to be able to type math directly into it. And then we can extrude that out. You can type 3 feet and it'll convert it to 36 inches for you. And then when you do it, you get your nice tube that's actually 16th wall. Have you fixed yours yet, Yan?
Sure.
Fix it! Everyone measure your tube, evaluate, measure. You can come in and see the inside diameter. You can see it should be 0.875. You can see the outside diameter is 1 inch. If you click the 2 different faces, I won't actually give you that. Measure, evaluate tab up at the top, and there's a measure button. Then you get this nice window. So then you can see the different diameters. If you just click inside the whole face, it'll actually highlight the whole cylindrical face, and it'll give you a diameter. You can do the same with the outside. You can also, you don't see measure? It should be to the second to the left one, yeah. Couple measure tips. So if you've already like clicked on something and you say you want to now measure like between the 2 faces to see the length, it'll do something really annoying and give you like, it'll still select all those faces, which is awful and no one wants that. So if you just click out in blank space anywhere, it clears the measure tool for you. And then you can bring it back and click into a new face, and then go back, middle click to rotate again, and then select this other face. And we see that it is in fact 36 inches long like it's supposed to be. Alright. People have actually 0.875 inside diameter tubes? Not yet. It's very convenient, Ian, that your monitor is so high that I can see it. What? Can you sit on the other side?
On the other side, so you can
Hey, you want to see something interesting? I can change all of the computer monitors. I have way too much power. What? Yeah, I don't. What seat are you at? I don't know what seat. If I knew what seat people were at, I could do it properly. There we go. So there we go. Now here's yours, and now I can now send to all, and now everyone sees what's on your computer. Yeah, I know. That's why I really like this lab, and I'm glad we were able to do it in here. All right, back to instructor laptop. Go send all. Okay. Maybe eventually.
My tube is just hovering over a table. I guess it has no concept of gravity.
What's with table 4 does not like me. All right, I'm glad no one's sitting over there. Table 4 does not work. I don't know why. Was it working before? Oh, there it goes. I got table 4. No.
I gotta fix it again.
Are you serious, Ian? Ian, this is ridiculous. Outer diameter 1 inch, 16th wall. Inside diameter is 1 inch minus 1/8.
Actually, I didn't. I don't think it's fine.
Did you fix it? Make your part correct. Okay. Everybody else happy with their tube?
Yes.
No one else like Ian? That's a very good thing. Good job. Don't be like Ian. Okay. Hey, look, we're streaming. All right, good. What am I looking for? Okay. So, like I said, that's for the most part, that'll allow you to make a whole lot of parts. Being able to do that simple sketch and extrude and cut and all that kind of stuff will let you make most parts. Okay, we're going to go into, really briefly, the next cool thing we get to do, which are assemblies. So we're going to go to New again, and we're going to go to Assembly. Except I forgot a step, which was we need to save our tubes. So go back to your tube and go to Save As. Make a folder on the desktop or something with your name or something along those lines. Name the part something convenient that you'll actually remember what it is. Okay. Alright, so after we save that, we're going to start into assemblies. Alright, so we'll do File, New, and we'll make a new assembly. Since you have that part open, it'll actually show up for you in your Open Documents drag box over here. If you wanted to start the assembly with some other part that you didn't have open, you could hit Browse and you could go through your computer and find those parts. But we're going to go ahead and use the 3-foot part. So you can actually just click on it. When you come out, you don't have to drag or anything. It'll just be kind of at your cursor. Go ahead and place it anywhere, and it'll put it in for you. So now we have this tube in this assembly. So what we want to do now is we're actually going to make another part. So I want everybody to make what do we want to make? Let's define a new part. A 5-inch by 5-inch by 5-inch rectangle with a 1.003-inch hole going through the center of one of the faces. Sure. Cube with a hole through one of the faces that's slightly bigger than 1 inch, because in this, yeah, you're going to make a new part. So go back, the same thing you did with a pipe. We're going to make a new part. We have the assembly. We'll make a new part. We'll save it. We'll put that part in there as well. It's a good habit to start making parts that are real. So in real life, you wouldn't be able to take a 1-inch pipe and put it into a 1-inch hole. It doesn't work. It's very, very difficult. But a 1-inch pipe into a 1.003-inch hole is actually reasonable, and you can press fit that, and it'll actually work. So if you were laser cutting stuff, you can actually do it. So figuring out what your dimensions are and things is useful.
How did you add that part into the assembly?
Okay, so depending on where you are, if you didn't just open the assembly and it's not there for you, in the Assembly tab, there's an Insert Components button, and it'll bring up this side window for you. And then it'll be over on the side. You can click on it, and it'll just be at your cursor. And you just click anywhere in the window, and it'll be put in for you. Did you save the pipe?
Yeah, I did save the pipe.
Did you close the pipe?
Yeah.
Oh, there's your problem. Okay, now that you've closed the pipe, you have to go to Browse, and you have to find where you saved the pipe.
Wait, what menu is that in?
All right, so as soon as you hit Insert Component,
Okay, it's grayed out for me.
what is happening? All right, coming over.
This is what we need.
Alright, click. Alright, there you go. Alright, save everything. Okay. Please, when you save things, name it part numbers that you can, part names that you can actually recognize. You will like your past self much more when 3 years down the line you go, where did I put that wheel I designed 3 years ago? And you can actually find it.
Does it matter what the diameter of the hole is?
Yes, the diameter should be 1.000 or 003.
Wait,
Where?
how long is the depth?
No, I want the hole all the way through.
Oh, okay.
Sorry, yes. Hole through one face, all the way through the part. Try to center it on the face if possible. There's a couple different ways to do that. There's numerous different ways to do that, actually.
You have to?
Center it on the part?
Yeah.
You should try. Since you know it's a 5-inch face, you know the face is a 5-inch square, you can use the Smart Dimension tool and you can dimension off the outer lines of it to the center of the circle by 2.5 inches. You could draw construction lines and make an X, and then it'll give you a point that you can drag to. And how big is your rectangular prism?
Sorry.
That is not a cube. Is it a cube? Oh, it is a cube.
I showed
Ah,
you.
good job, Ian.
Yeah. I
When you finish your part, save it as some part name that you can recognize. If you want to get ahead of the game, you can save your cube and you can insert it into the assembly.
Oh, so are we going to stick our, like,
Yeah, only two.
Save your part, then go back into the assembly. Why are you only have to be close to the assembly?
I think that's how you do it.
You got all your parts though. Where all your parts go? Why did you not save the tube? Did you save the tube? Make the tube now. How did you do it? I don't know how you managed to do that. Alright, you have a tube and a pole. Are you working on getting it?
Yeah,
The
yes.
tube, whatever, you can use the tube and stuff.
So we're going to stick it in the hole, right? Is that right? Or keep it?
Just like on the tube. Like a bunch of buttons that you all stuff. He's now stuck it in the hole. Have you used CAD before?
I know, we
There
gotta
you
keep
go.
it straight into the hole.
In there. Make it go all the way. Really cool. Extrude cut, but you want to, if possible, you want to put that in the center of the face. So when you edit that sketch, you can dimension from each side. You can dimension, you can do 2.5 from each side. And it'll make sense. And then you go for the top two. Oh, you gotta click and it'll let you bring them up. If you're through that far and your hole is not in the center of the face, work on getting it in the center of the face. You can edit the cube actually directly in the assembly. We'll show you over that in a second.
I think it's fixed. That's why I just
So they do this in the scanner. Oh. And then you can type 60. Make gearbox. Yeah, make the 1-inch pipe to 5-inch tube gearbox. What? That's a thing? Yeah.
I didn't. I didn't.
You have a hammer now? Yeah, that's kind of what I'm that I'm just making a shape off the top of my head and making it all. It's quite fun to have power. I can make high school children draw all the shapes. How can one man have so much power?
Alan, you've changed.
It's gone to my head. Alright. Alright. If people want to see how to make the cube quite quickly, we can generate a new part, sketch.
I broke it again.
How?
When don't put the parts, they won't come out.
Gosh, I don't know what I'm doing.
Stop breaking the assemblies. Good job. Cannot locate into featured. Well, because I'm not very good at this sometimes. Alright, so most people have the cube with the hole. Alright, okay, so some of you may have already gotten past this, but when you go to insert multiple parts into an assembly, you're going to click the Insert Components button. If it's open, it'll be in your nice open documents list right here of all your saved parts. If not, you have to go to Browse again and find it. You can click on Cube with Hole and bring it in. And then we want to start having them interact somehow. So a couple things to notice. So the first part you hit, if you actually click on it and you try to drag it, you're not going to be able to. So because you inserted it first, it automatically defines that as fixed. So if you right click, you'll see there's this little float button here. And if you right click on the cube that you inputted second, instead of saying float, it says fix. So inside of an assembly, you have two options. You can either have something that's fixed or floated. For the most part, you only want to have some single entity as fixed, because then you're going to reference and mate everything else to that. So whatever your base fixture is, you want that to be fixed. So in this case, we already started with the pipe, so that's fine. We're with the tube. And then we're going to use the next button in the assembly toolbox, which is mate. And mate's pretty smart. There are a ton of different mates that you can do. So if you wanted to connect the pipe or the cube to the pipe, instead of going through the center of the hole, if you wanted to connect one of the faces and you wanted to click on it, it would now be tangent to it, and it would make sure that that would never be able to not be near that face somehow, and it'll do really weird things when you do that. But not a big fan of that, so we're going to undo that. Instead, we're going to click on the interior face of this part and the exterior face of that one, and it'll automatically set it up to where they're concentric, so it chooses the concentric mate for you. That just means the two circles share a center point. Yep.
My mate button is grayed out.
Your mate button is grayed out. That normally means you're in some sort of other window. Tap escape a few other times, see where you're at. What are we doing?
It doesn't look like I'm learning something. There's a detail layout.
Yes, you are in a layout sketch. Again, come back to it.
Oh yeah. Why does it say mates right here?
Why does it say what?
Mates right here.
Well, I'll show you that in just a second.
How do you insert the cube into the...
The cube. Insert part in the assembly tab. So go ahead and exit out of mate and everything because you don't want to be mating right now. Exit. Yeah, assembly. Insert component. And then there's your cube right there. You can just click and then just click on it and then mouse it up. Click. And then you can do the mate thing that I just did. You can click on those two.
I made my tube big.
For right now, it'll be fine. It'll mate it either way. So just go ahead and click off of your tube first, though. So whenever you're going, small tip, real fast, guys. Whenever you're about to click into a feature, if you have something selected, it'll think that's what you want to act on, and it'll get really annoying on occasion. So often it's a good habit just to click somewhere in a blank space so you can deselect everything and then go into the feature you want to do it. Or if you know if you want to use that feature to your advantage, it's fine. So like if you want to do those two mates where you're going to put it into the hole, if you selected the outer face or the inner one first and then clicked mate, it'll automatically choose that face as one of the ones you're going to be using. But it can be really annoying if you just accidentally have something clicked, you go to mate, and then it tries to mate something off to the side that you didn't even know you were selecting. All right. So do most people have it mated together, at least with one mate? Mary, where'd your mate go? Your tube's not in the circle. It'll still work. 1 inch, but it'll still work. Just hit mate. Just what are you doing? Hit mate. And now you're gonna click on the exterior face of the tube and the interior face of the hole, even if they're not. SolidWorks doesn't care. SolidWorks doesn't actually know about size. Left. So yeah, SolidWorks will very gladly let you make impossible things. So if you made a tube that's too big for the hole, SolidWorks will very gladly let you shove that tube inside the hole that doesn't actually fit. It is no way. There's no way to care. There's no way. Like it'll know that it's interfering, but it'll happily let you do it. Good. Okay. So most everybody has that down. So we're going to add a couple other things to it. Okay. So a couple people asked what this mates folder down over here does. So when you're in an assembly, this will list every single mate that's ever in your assembly. So when you end up with when you're dealing with a full robot, this gets absolutely huge. So you actually I don't often look at it in the full mates folder by itself. You can go into each individual part, and each individual part gets a mates folder, and then you can see what mates just account to that part. In this case, there's only one mate that accounts for both parts, but if you start having a lot more, this is far easier. So you can go in and you can edit it if you wanted to change how it was concentric. This button right here actually flips the dimension of it. So for this part, it doesn't matter because it's symmetric. But for parts when it's not, it's often important to figure out which way you actually want it to be concentric and which way you want it to be mated. So this aligned and anti-aligned button does that for you. The other way to do that is just to right click in and do flip mate alignment, and that'll flip it around as well. Again, it's not necessarily all that obvious to notice what's happening. Wait, how did you guys, what happened?
What did you just do?
I don't know, somebody managed to get the screen off. That was weird. Let me get back to, I don't know. Get back to my screen. Yeah, I'm not really sure how that even. The other ones are right? There it goes. Okay. Okay, so what I was showing was that you can flip the mate alignment when you actually go to do a mate. If you try to mate like a bolt to a hole or something and it's not looking right, if you hit this button, that'll fix most of it, because it's basically, there's two different ways that you can mate everything, and it lets you fix it. If for some reason you've already mated it and you want to flip it, you can use this flip mate alignment button right here as well to do the same thing. Okay, so we have it to where right now it's able to rotate and move all over the place. If we want to make it defined a little bit more, we can hit mate again, and we can mate like one of these faces to the bottom face of the tube, and now it'll have, now it won't be able to slide in that dimension, but it'll still be able to rotate.
Can you like made it to a plane so you can just like...
You are ahead of the game. That's actually what I was about to do. So yeah, so the planes are really nice because you can tell it all sorts of things about planes. So if you click on any of like the front, top, or right planes, and you zoom out, they'll show you where they are. But you can also hit, you can make them be shown by hitting the little glasses, and you can show the different planes as well. Though sometimes they're not shown because up in your view window, for some reason, it decided to hide planes because, you know, SolidWorks wanted to do that. But now you can see them. So if you want to make sure that, if you want to stop this from rotating, and you say you want this face right here to be parallel with the right plane, you could hit mate. You could select both the right plane and this face. This brings up a little error that says the default mate type coincidence would overdefine this assembly. So basically it's saying, if I try to make that face touch the right plane, I can't do it because that pole's fixed and I can't drag it, so SolidWorks doesn't know how to solve it, so it gives me an error. Because that's right, it's trying to use coincident. But if I tell it to use parallel, it'll be perfectly happy. It stops bugging me, and I can select it. And then I can't rotate this at all, and the entire thing is fully defined. There's actually a little bit of text in the bottom right of the screen that says fully defined right there. And if you, for some reason, if you don't have one of those mates, if you were to get rid of that, it'll show up and say underdefined, which basically means there's some degree of freedom. In this case, this can rotate.
I can't see the planes.
If you go to view,
Yeah, I did. I keep on probably to all it on and off.
did you go to the planes and do show?
Okay, is it on now?
Yeah, so on each one of the planes, you have to put the glasses and hit show.
Oh, cool.
Yeah, so there's the feature tree will have a lot of different hidden parts. So actually, if for some reason we were doing something and we didn't want to see the cube for some reason, we could right click on the cube in the feature tree, and we could hide it. And now it's not visible. If we wanted to see it, but we wanted to be able to see stuff that's inside of it, we could right click and we could hit change transparency. And now we get a transparent cube so that we can see the full tube inside of it. And you can also select through it. One of the more important things to remember, and this is one of the ones that a lot of people don't learn pretty early on in SolidWorks and they get really frustrated. So if you have a transparent object, if you click on something through it, it'll always click straight through the transparent object to that background thing. If there's not something in the background, it will click on the transparent object. But the other way to force it to click on the foreground object, the transparent one, is to hold the shift key. And that'll actually get really, really useful down the road. So if my mouse is here, normally if I just click it's going to be on the pipe, but if I hold shift and click and I move a little bit, it'll reselect to the face of the object and won't click through it. So that works with all transparent objects, and that'll get really, really useful when you start getting bigger assemblies and you have like all of your electronics hidden, or you have a side rail of the robot transparent and you're trying to click through it sometimes and things.
How do you make it transparent?
How do you make it transparent? So in the feature tree, you right click on either of the parts that you want to, or whatever part you want to make transparent, and there's a little button right next to the hide button, that is change transparency, and it'll pop up the little balloon tip that shows you what it is, or the little help text. They're basically the same icon. One is just slightly lighter, that means it's transparent instead of hide. The other thing that you can do once you're into assemblies, and actually you can do this with features too, but we haven't talked about it, is you can suppress them. Suppressing basically is like deleting the feature, except you can undelete it later. So if you wanted to completely get rid of the cube basically out of this assembly, but you thought maybe you want to put it back later, or you just want to see what it's like without it, you can completely suppress it, and instead of, if you just hide something, all of its physical properties are still there, all of its mates still exist, it's just not shown. If you suppress it, it gets rid of all of those things. It's like it's not there, but all those things are very easy to come back because you can just right-click again and use the other arrow, the up arrow now, and unsuppress. And all of the stuff comes back without you having to do anything. So this is really nice. So you could have different configurations of wheels on a robot, and you could suppress one set and unsuppress the other to have different models, or different parts of a robot, anything like that. You could very easily suppress and unsuppress and basically look at the differences. You can do that a lot with this thing over here called the configuration editor, which we'll talk about later, that basically lets you save some of those different suppressed and unsuppressed components. So you could have a model of your robot that had the ball in it, and then you could have a different configuration that didn't have the ball, or that had the launcher in the up position, and things like that. Okay. Let's see. A couple other things we can do. So just like we did, we can do linear patterns inside of a sketch, and we can do linear features inside of a part. We can also do linear components. So if you click the linear component pattern, you have to give it a direction. And so the directions are normally some sort of vertex or some line that you can click. So any edge of the cube is fine. You tell it the distance apart you want it to be, something like 10 inches. You tell them how many you want, something like 4. And you tell it the components to pattern. In this case, I want to pattern the cube. There's a reverse direction button right underneath the direction 1 that you can click.
That screen went off.
Calm down. Just listen to my soothing voice. It'll work. You'll figure it out. There we go. All right. So linear pattern. I'm coming back. All right. Linear. Really, Mary? All right. Linear component pattern. So you click on the button. You click on a direction, which is any like edge. Doesn't matter which one, as long as it's along the same plane you want to, or along the same line you want to do it on. Give it a dimension. 2 inches works fine. Tell it how many. We can do 4, and then you have to tell it what components to pattern. So this box down here, if you click in it, and then you click in the cube, it'll do it, except I don't want them that way. I want them to put them all on the pole. So I can come back over here and do reverse direction. And now that gives us this weird shish kebab of cubes. Each one of them is in the pattern, so if you edit one of them, it'll hold the pattern and it'll make sure to leave the pattern the same way. So if you move it, it'll continue the pattern. All of these parts are instances of the same part. So if you modify one of them, so we'll do that in just a second. It'll modify it on all of them. So how do we do that? So say we were given this assembly. Somebody had this. It was some weird robot part. And they wanted to modify this cube and make it a little bit smaller. They didn't want it 5 by 5 by 5 anymore. They wanted it 4 by 4 by 4. To do that, you can either you could go back, you could open the old part, you could save it, all that stuff. But if you're in the assembly already, who's talking? Stop it. I'm so mad. Not really. I don't. Okay. This menu when you're in an assembly. This menu gives you a lot of access to all the different stuff you can do with a part. If you right-click it either in the window or over in the feature tree, it gives you mostly a lot of the same options. Not all of them, but most of the same options. One of them is open part. One of them is edit part. So you can actually edit the part. Of course, okay. We need to save the assembly because we should have done a while ago. We just hadn't. Day 1, assembly 1. Okay, once you save the assembly, it'll actually let you edit the part directly in there. You can notice you're editing the part because it's going to say edit component and it's going to be clicked on right here. In the feature tree, everything about that part is going to be in blue. And most of the time, the other parts are going to be transparent, which makes it really easy to actually edit that one part. But you can actually play with that a little bit. If you go to, there's an assembly transparency button. You can turn them back to be opaque. You can turn them back to force transparency. But now we can actually edit this part directly. So if we wanted to change this part to no longer be 5 by 5 by 5, there's a few ways to do that. The first, we can edit the extrude and make that 4 inches. So now that edits that to 4, and you can see all of the rest of them changed. So all of them are now 4 inches long. And if we're back in here on the feature tree 2, we can go down a level and go back into our sketch, and we can edit the sketch. And now we're actually editing the sketch directly in the assembly, so you can actually see everything in relation to it. You can see the pipe going right through it and everything. And we can make this 4 inches. And it seems like it's going to update wrong because now the pipe's not in the center. But if we dimensioned everything properly, which I'm not actually sure that I did, it'll fix itself. Yeah, so when I exit the sketch, it actually realized where that circle should be and actually fixed itself. So that quickly I was able to take a lot of volume off of those cubes, and it all updates and it all knows where everything is and it saves. When you save the assembly, every individual part in the assembly saves as well. So you'll have all the parts are updating all the time. So don't think you can put something to assembly, modify it a bunch, save it, and then have the old version of the part. You won't. It's referencing those part files directly. Questions? Anything? No one ever asks questions.
Yeah, how do you keep the circle concentric?
So, okay, keeping the circle concentric. So that's just basically determined about how you've drawn things before. So as you start getting better and better at it, you'll learn what SolidWorks will be able to update and what features you want to stay the same. So if you knew you wanted to always keep it center, but the dimensions might want to change, you would draw it to where you didn't dimension it. So when you drew it, you dimensioned it 2.5 inches off of 2 walls, it's going to always put it 2.5 inches off of 2 walls. So if you drew it to where you forced it centered, like when I was sketching it quickly, I did. Let me show you how I sketched it real fast. So when I sketched that hole, instead of dimensioning it, I used those construction lines we were talking about. I drew those with, you see that little dot right there? Why does that get bigger? Whatever. So that little line with a dot in it means midpoint. There's a midpoint line right here. And what that means is it's going to be the midpoint of this top line. So it's actually referenced this line. This one's always going to be in the midpoint going down. This one's always going to be in the midpoint here. They're construction lines, so they don't get in the way of my feature at all. But I can put the circle dead center on them. And no matter what I change the dimensions to, it's always going to be in the center. Even if I made it a rectangle, I can make it whatever I want. And as long as these lines stay, it'll always be in the center. So you can do, like I said, there's lots of different ways. There's multiple ways to do the same thing, but later on they'll update different and they'll do a bunch of different things. It's not a hard thing to go back and fix the sketch. If I didn't have these, I could just as easy from here come in, click on the center point, using the Smart Dimension tool, putting it in as 2 inches and doing the same thing. If I could actually click sometimes, there we go. And making it 2 inches too. And that'll do the same thing. You would just have to update it yourself. But it'll do the exact same thing. Yes?
My hole is no longer in the center. How do I fix it?
Actually, literally what I was just talking about. No, it's fine. I'm not. Oh no, I'm just saying that's okay. So you want to go back. So down in your feature tree, you should have some sort of cut extrude or some way that you put your hole in the center. And you can edit that sketch again. And then in the same way that you put it in the center before, you can recenter it. And you can do it right inside the assembly, and then once you're done, you can just click the edit component thing, and it'll bring you right back. Okay. I have this feeling I'm missing something. I don't know what it is. No. Yes.
I'm very confused. So I'm looking at the sketch that I did the cut extrude from, but the circle isn't where my hole is. So it's
The circle isn't where your hole is.
where the hole on the actual shape is. It's down here, and it's there.
That's just perspective.
Oh. Yeah. Okay, thanks.
You're welcome. Yeah, if you see something that doesn't look real, clicking and dragging, rotating, a lot of times fixes perspective. So you're selecting the direction first. So you're going to select one of the vertices. That'll set the direction. Then when you actually, then you can set the dimensions, you can tell what you want to change it for, and then when you want to select the actual component, you'll do components and patterns. You put that on. Oh, I broke the handle on the bucket. Well, I did. I was just carrying the bucket. The handle on the bucket broke. I did not break it. I didn't break it. The handle on the bucket.
I think the finding break it dozens of dollars. Literally dozens of dollars.
I guess it's going to show me $40. Yes.
I wrote a suit for $30, but it doesn't make it.
How are we going to carry it down?
Let's CAD the handle.
Not like the handle goes. Just like
Let's CAD the handle and have all of it.
yeah, we're not at that point yet. Questions, people on the right page? Sort of? One's close. Did you fix your whole diameter yet? Go fix your whole diameter. Yeah, you can look at the feature tree. So, hold on your cube. So on the other extrude, you would edit this. You edit sketch right here. So that means your pipe is wrong.
No, it was something different. Except when I did that, I accidentally messed it up, so now
So you never did the outer dimension of the pipe? You never dimensioned it?
The cube
So
is
smart dimensions. You have it at 1.9, it should be 1. There.
Plus extruded.
Where it says pipe. Happy random boxes and holes in the. I think of such cool shapes.
We should make a lollipop.
It's literally the same thing. It doesn't change anything except for you have to cut a hole through. Well, it would be. It would be somewhat different.
It'll be funner than sticking off.
Well, no, because you're gonna have to cut through a plane depending on how you do it. You have to cut through a non-parallel plane to the circle. Yeah, we want to get all the way there. I'm trying to figure out if we want to go all the way to that point yet. If there's anything we need to step through before we get to reference planes. Because if you imagine a lollipop, you have to cut a hole through the side of a circle that's not parallel there. Relatively, it's not too bad, but I'm trying to figure out if there's any other. No, you definitely can. I'm just trying to figure out if there's something you need to know before you have to do. Right. Well, yeah. So you draw, you make a reference plane. We can walk through it in just a second, but I'm trying to see if there's anything else you need to know before we get to that step. If we have to learn something else. I don't think so. All right. People want to draw a lollipop, so we're going to draw a lollipop. How do you CAD taste? First, you buy the smell-o-vision. After you have the smell-o-vision, you use the you get a little smell-o-vision tab here because most of taste is smell, so that's the important part. What?
Yes.
Yeah, it's pretty expensive though. It only works with SolidWorks Premium too, not the educational version.
So you can actually CAD taste, like that's for real? That would be awesome if it was. That's another thing.
I'm gonna get a sarcasm light somewhere. Okay. Right. So. Reference plane. So before I set you loose attempting to draw your best rendition of a lollipop, reference planes will come in really handy for this. So if we have this tube and we want to sketch, actually you don't even need to actually do a reference plane. You can do it without one, depending on how you make it. But reference planes are useful, so we'll do one anyway. So if we open up, if we go back to the tube part, however you want to get there, you can do file open. If you are in your assembly, you can right click on it and do open part, and it'll actually take you to the whole part by itself, not in the assembly. So say we wanted to drill a whole line of holes down this tube. There's no really simple way to do that. I can't just create a sketch right on the diameter of this on the circumference. It's not going to work. It's not actually a flat 2D surface. So I have to basically tell it to put a 2D surface somewhere that I want there to be one. So to do that, you can use this handy feature over here called reference geometry. And in this case, a reference plane. So if we select this and we tell it to be tangent to it, then you can define it a little bit more if I knew where things were. That one. What I just do? Reference geometry inside features and plane. And then I'm going to click on the part. And so that's going to tell me the only option is tangent. So if I just left it at that, it would let me, I would have now a plane that I could sketch on that was tangent to it. But if I wanted to tell it a little bit more, I can define it next to the top plane, and I can tell it it's either perpendicular or parallel to it. And that way I can know actually exactly where it is. So I tell it it's parallel to the top plane, it's tangent to that face. I know exactly where this plane is now. Why is it being weird? Okay, there we go. So there's this plane in the background, and if we go back to sketch, we can select it. We got to make sure it gets highlighted orange when we click on the sketch tool. And now we have this plane here, and we're sketching on top of it. So in the same way we did before, we can draw circles. If you come up to the top and you catch the center line, you can know that that little blue dot will mean that you're on the center line, and it'll let you drag on it. So you don't have to change it yourself. And we can put 1/4 inch holes right through the center of the pipe. We can figure out some hole spacing that we want for them. And in the same way that we've been cutting holes the whole time, we can extrude cut. Oop, lost the part. We can tell it to go all the way through. We can come back and look and see that it's doing that. Yeah. Yep, of course. Where did you leave off? Did you get a plane yet or no? Okay, that's cool. Reference geometry is one of the trickier bits to start getting used to. Okay, so reference geometry, plane, and so when you start referencing planes, there's lots of ways to define a plane. You probably went through a bunch of them in your geometry class at some point. If you have 3 points, you have a plane. If you have 2 lines, you can make a plane. There's lots of ways to make a plane. So it gives you the ability to do it off of 3 points. You have 3 different references you can possibly use. The first one we're going to use is the pipe itself, the exterior, and it's going to force it to be tangent. That's the only thing you can make a plane to a cylinder is tangent. The second reference we're going to make to one of the planes that already exists. If you don't do this, it's not a big deal. It'll just be, that plane will just be somewhere along the exterior of the face. But if you come into your feature tree, which is normally over here, moves over to the right when you're trying to select things, and it gives you an ability to select through different parts of the part itself. So you can grab the top plane, for instance, and now you can set it perpendicular or parallel, and you can define it in relation to that top plane. Does that make sense? That worked for everybody? Okay, now I have multiple planes, but back to the original one, do the exact same thing you normally do. Sketch, click on the plane itself, and that'll put the sketch there. And then when you drill through, you can see that it's actually drilling through the proper way. It's going through flat, so you get that like curvature you would if you were actually drilling through a hole, drilling through an actual pipe. It knows how to do all of that for you. You can, in the same way we've done before, you can linear pattern things, so we can tell it to go along. Oh, actually, that would be tricky. So in this case, well, let me. Aha. Yeah. When you tried to make the plane. Let's see. Oh, sorry. So it's on the right plane, click on the top plane. Yeah, click on the top plane. Okay. See where we are in space.
Yes, it is right.
Oh, you have a third reference. You need to delete your third reference. There we go.
Okay.
So,
Do you
yeah.
need a third
Yep,
reference?
we only need 2 in this case because it's fully defined just by saying it's tangent and parallel or perpendicular to another plane. It's fully defined.
Okay.
So you're good to go.
Great. So now you put a hole through it?
Yeah, you can put a hole through the pipe. You can put multiple holes through the pipe. You can do whatever you want. Yeah, you could linear pattern it to make a flute, which should work if you select the interior, but no, so it's going to want to do that. So this is actually a bit of an interesting thing. To be able to linear pattern across something that doesn't have a line, we actually need to use a different type of reference geometry if we wanted to. You can use a reference axis. And in this case, we can select that, and it'll actually give us a nice little, what looks like a construction line, basically, right through the middle of our pipe. And because of that, we can then use that as the direction for something we want to pattern, something like those holes. Now it's trying to pattern 96 of them, or 95 of them. I don't really want that many. I want like 35. Nope, not even that many. I want like, how many carbs do I want? I want like 15 at a 2-inch interval. Nope. I want like 17. There we go. Yeah. So then now we have 17 1/4-inch holes on a 2-inch interval going down the pipe. So click on sketch, and then you're going to click on the reference plane that you just drew. Oh, you made a circle and everything. Oh, okay, so then you're just going to go to extrude cut. actually a good example.
So
People want to
good
see
enough.
two. No, I've been waiting. I haven't done this yet, and I was expecting to do it.
Oh, thanks, Alan.
I know. I was serious. I've been wanting to do this. I just haven't. Okay. So this is an error message that will come up a lot at some point in your life. Cannot rebuild feature using this sketch. There is some problem with the sketch. So most of the time, if you hit show the problem using check sketch feature, blah, blah, the sketch has both open and closed contours. What that basically means is somewhere you have a line that isn't a closed shape. So you just have a line somewhere in your sketch. Right, but in this case, you did not put it for construction.
That's a lie.
But you think you did. So there's a pretty easy solution. He thought he had a construction line, but he didn't. So by making that line construction, we'll most certainly be able to yeah. And it works. Oh, well, so where he oh, you missed the part right there.
Wow. I need to fix it because it already happened to me a few times.
So for people who missed it, we need to put a reference axis through the center of this part, which is very easy. Just with reference axis, click on the inside face, and now you have that axis. So when you go back to do linear pattern, your direction is across the axis. If you can choose the features.
Can you just click the circle? It will give you the same axis.
Maybe. Having the axis.
Yeah.
Oh yeah, can you make this one? I've been asking, I've wanted to ask you for a long time. I think that's weird.
Yeah.
I'm so afraid of results. I was afraid of
I can't in fact make it lower because it's a monitor on. Alright, if people want to attempt that, you should have everything you need in your ability to make a pretty decent lollipop. I don't think there's any reason you can't. Make it a reasonable, try to make it actually dimensioned to whatever size reasonable lollipops would be, so namely not 4 feet.
Make a lollipop the size of you!
Not a reasonable size lollipop. You can figure out ways to make, we went over how to make rounded corners, so if you remember how to do that, you can figure it out.
Fillet.
Fill it.
Not fillet. Fillet.
Right, 'cause it's not a fish.
Can I use a zebra shape? Can I use a zebra shape? It's actually it's
Do whatever ability you want to make the most accurate lollipop you want to make. Go. You are losing the race already, Mary. You-
Oh, wait. Should I raise my hand? Do I need to be Alan?
that way and to the right. When you hit the wall, make a right.
Can I get a drink of water?
No, not at the same time as Mary.
Is that a roll
You'll
out?
get up to no good.
Where is it?
Tally to the right.
Lights are off. I'm scared.
How big is a lollipop? How thick is a lollipop? I'm pretty sure. Has anybody not had a lollipop in their life? This will be very difficult if you've never had a lollipop. Have you seen a lollipop? Perhaps an episode of like SpongeBob SquarePants that had a lollipop on it, perhaps? Some mental reference to a lollipop. Does the word lollipop mean anything to you at all?
A little. Some one that's really oversized.
Matthew, make a lollipop on your own view.
You can get the What kind of lollipop?
What is a radius of a lollipop stick? Part of this task is to make the most realistic lollipop you can from memory. Judge what you think lollipop should be. Perhaps you have resources at your disposal. Right now, no. Yeah, you're not using the. Whatever you would like
It's not working. It's everything.
That's like 7 meters away.
Basically.
Yes, you did. You actually said that. That was really weird. You start talking in meters.
No.
It's really funny.
It was my whole idea. What?
Early this morning, she was saying meters a lot. In your head.
Well, whatever, make a lollipop. Nothing that happens before like 6 a.m. counts anyway. That was way too early.
Well, here's the entire day. Do we have to sign up for that? Is there a sign up sheet for that?
There is. It went out in the HTML email that no one read, and I don't think anyone signed up. I'm gonna send out another one. It's really good.
Okay, I was like, did I like miss it?
HTML email, HTML newsletter at the bottom has upcoming events. There's also a sign up for this thing.
I didn't realize. Speaking of Google,
It's a Google thing in the HTML email. It clicks and does
like
it.
which one?
In the newsletter one, just like Thursday. What's around? It's like a 2 weeks away, like a week and a half. It's forever. I don't know if it's covered. It also included like one other tweet saying his Facebook page. Obviously.
Never.
But yeah, I will send out another round of sign up. It was in the HTML email. You proofread the HTML email.
Alan, we're gonna have to be touch what happened. I created like a flute and I saved it as something different from like my like whole hotel, like in my you like what?
So
Can I go back having to pull the
only by like suppressing that feature. So you can right click on the in the feature tree, you can find the part that is, or the couple ones that are holes, and you can suppress them. But so what you ended up doing was SolidWorks knows that you're referencing the part. So when you went and opened and edited it and you put holes in it, it's doing that exactly the same way as it would be in assembly. It's the same feature. So doing that save as, pretty sure it saved as a new same name as it, didn't it?
No, it didn't give it the new name. I saved this new part as flute, and then like the original whole was like long so.
Oh, but because you had still been editing that one and you didn't do the save as and like reopen Flute, it'll still do it. But Flute's still there, so it'll still exist. So if you go back to long number, if you like click on that, click on the drop down arrow next to long number. So you see the cut extrude right there. If you suppress that little drop arrow, the little right to the right, the little down arrow from like the yellow part to the right part, up one. That one suppress.
Yeah, but then it's not but it's still the flute. It's just you can't see the holes in it.
No, because what you did was you took your long pole or whatever, right? You put holes in it, then you saved it as a flute. So the long pole itself had holes in it because SolidWorks just knows that it was the long pole the whole time. So now if you go open flute, it knows the different part.
Wait, if I open long pole, will it put holes in it now?
It'll have the suppressed part that you just had. Like you can delete that part and it'll have holes in it anymore. But you can open flute, it'll be different because the save as is where that tree basically branches. Everything before that save as, you were modifying the same part.
Okay.
So yeah, but
What material is that?
Now, how do you?
Oh, I see.
Oh, it's like not hot.
what? Make all of them. Smart dimension. Why is there a hole in it? What kind of lollipop are you making? I don't know what type of lollipop you make, but make whatever you want. But use smart dimension. Smart dimension is useful. I'm gonna measure your dimension. Don't make 4 foot wide lollipops. Make reasonable size lollipops. No.
But it is a reasonable size. Look at this, fill it.
I have no idea.
Fill it.
You know it's not like,
It's
you
on
know
the
it's
top,
less than an
so
inch.
fill it.
You know it's not.
Figure it
scale.
out.
That literally could be anything. It's not scale.
Why does no one here know what
Part of this whole goal is for you to actually start designing things now. You can go like you have to go look up where the dimension of a lollipop is if you want.
How long is this? How long?
And how long is that? Find a way to figure it out.
Alex, you know I'm trying.
Yeah, knowing rough ideas of dimensions.
I'm making this giant lollipop.
That's fine.
So
It's a
going to be
lollipop?
huge dimensions.
That's not huge dimensions though. That's how.
It's going to be like a 5-inch.
How small do you think a child's face is? No, like it was bigger than her face.
What? You don't think it's 5 inches across?
I've seen some pretty
At
big
least.
lollipop.
How small
Yeah,
is
I
that
said at
child's
least.
face? That's Bella's face like 3 inches. That's wider across her face.
Alan, can I make the
Holograms only do what you tell it to do, so you don't have to be able to design things.
Can it be cast alloy steel?
That's probably not a very tasty lollipop.
Air. You can choose air as the material.
You can choose air?
Yes.
I feel like that's probably not the default. Maybe something got weird on your installation. I've never been able to choose air before.
Oh, there's also water.
There is. There's lots of very weird materials.
No, I mean, it has to be true. I want to make sure.
Water.
Why are you laughing?
So do you not store one, Alan? I didn't realize you had
Yeah,
an inventor.
that's all I do.
Where's the paper material? Get someone to have a lollipop.
I have a lollipop.
It's pretty. How thick do you think that whole stuff is? Like 3/4 of an inch, maybe?
You're supposed to, part of what you have to learn to do is judge things visually, scale, all that kind of stuff. I'm gonna take, I realized I was still.
When it's in sketch, yeah, it doesn't work.
I know, that's why I was fixing it.
Yeah. Yeah. Yes, there you go.
Where is it?
It's the top right, it's like a bowl.
Yeah.
So what are you in, right? So you're in the part still, right? But you don't want, so most likely it's gonna be assembly. It doesn't have to be, but it could be. Because the stick and the lollipop surface should be different. They don't make the stick and the lollipop do the same thing most of the time.
I don't know, that tastes really
Well, I've been eating it the
I mean, it's probably not too bad for you.
Good.
Do you also know that you can take the wrapper off of candy?
Did you know that you can't eat the paper on a muffin?
Everyone knows
I
this.
gave you a design requirement, and I said design a realistic lollipop. That is true, but I gave you a incomplete spec, and I demand a deadline, and I want a lollipop.
It's like software.
Give me a lollipop.
Alan,
I like first. Build me a whatever the name is, a aerial assist robot. That's all I'm telling you.
Alan, are you trying to vent like your anger that you've been receiving from all your clients, like on this one project?
No, no, they actually tell me things at least. No, I give you my worst thing. Like you can't do this. I'm like, that's features obviously needed. I don't feel needed.
They do that opposite.
Oh, you did the same thing as me.
Alan, you're gonna
We all did the same thing.
put us back at Synapse, right?
Is that a nice color?
No worries.
You can try with that, right?
Hey, you did.
Oh, you told the story.
How did you contest it and try it? Wait, how did I didn't realize something over here?
You tell them.
My mom was really busy, so we dropped off from their restaurant, at a restaurant they were just in. So we eat lunch there and wait until he comes by.
Are you serious?
You stayed like for like 2 or 3 hours just there.
Wait, how long were you? Where were you?
Jericho.
You were in Jerryville for 3 hours. Did you write on the chalkboard thing?
Oh no.
You have to leave a spectrum thing every time we go. It's not hard. Jerryville.
You don't have
Did you get a free milkshake?
Oh no, I didn't.
Wait, he went
I
to
didn't
free
know.
milkshake? Literally like 200 for 2 bucks. I didn't actually go there and not get a milkshake. But when I thought you went on people's bed.
I bought the cheapest possible thing.
You passed my dog on right here. It's on me.
I forgot how to add custom materials for lollipops. Oh, I did. I did.
Let's do something like
That's so pretty. Yes.
Does your do you have a hole in your lollipop?
Yeah.
What? Oh, you put a hole in the straw?
What? No. It's just
Oh, there you go.
Beat me to
Okay. They
it.
make spears. Remember when we did the revolve thing to make a cylinder? Your hint. Use the revolve
I
tool.
thought a revolve cut.
But you need revolve not cut.
Oh, thanks.
Well, you can do it with revolve cut. That would be impressive. You can, it's possible. But you don't want
Can I
to.
Google it?
Sure.
Please.
Google, this is a open book CAD camp. Feel
Revolve
free to
boss space.
Google whatever you wish on SolidWorks. Don't Google whatever you wish. Just Google whatever you wish on SolidWorks.
You can't tell me what to do. Look, Alan, look. I Google whatever you do.
Oh my god. Where's your lollipop, baby? Go lollipop. No. You can't eat a virtual lollipop.
Oh, I was making a pan. I feel like it's hard to fill it in.
Well, you have to give it an active quotation. So for revolve, you have to give it a little bit.
You want to make a hole in this? First one, you want to put on there. And
Same way we made a whole.
It won't let me select. It just distributed into the group. You just assume those are This is a circle.
Oh, wait.
Yes.
And then I extended it. Circle. So it's like a small cylinder.
Yes. Oh, gotcha. So the whole thing is this.
Yes.
Yes. You have a lot. Okay, you have a lot.
Yes.
You have a line. But you have a sketch line. Now go to sketch. Now you can draw the circle there.
Okay.
And then you can cut into it once you have the circle.
How do you edit your face though?
We're not playing details yet. Details is like the last thing. Because the most useless thing is
But your face is the most useful thing to me.
Also, they would sell so much.
not giving you the power. No one. That would be just the creepiest thing.
That's gonna be our signature. Every robot we ever work on is gonna have your face somewhere.
Luckily, I have veto power on the robot. That will never happen.
It's gonna happen, Alan. It's gonna happen.
Finish the lollipops. Finish all of the lollipops. What else do I need to do today? Tomorrow we'll get into actual real assemblies of robot parts.
This isn't real assembly.
These are extremely fake parts that can make up dimensions off the top of your head. Ooh, we should actually model something real.
The backside piece.
Well, that's really, really hard actually. Like,
Why is it there?
I have no idea. I didn't bring that in. But that is the guy who made it was like, this took so long to get right in SolidWorks to be able to injection mold and stuff. And you have to make the model to actually be able to mold and like be produced. Who made it? What's his name? Who's former 148?
Just
It's always 148.
Well, yeah, but half of the names are back there.
Alan. Yes.
Remember, Alan.
This is like.
Jonathan Coates. But he makes wheels. Why can't he make more? Alan, why do?
How do I use the start dimensions in order to this mold?
That is a good point. So, actually, it's a good time to look at. Everyone's gonna see your computer now. I don't remember which one you are. E1.
He's 3. She's 3. 4.
Isn't she actually 1?
She's 4.
She's 4.
No, it's 5.
What does it actually say?
It's 5.
Okay. What?
No, wait. This was the one you had at home. Was it?
That's what I thought. I was 1.
Dang it.
I'm right, right?
Sarah?
Okay.
I thought you knew what your screen was showing.
Pretty sure. Okay, so one of the nice things that we can do, if you have a sketch on a plane and you want to get some edge that you can't get to easily, you can use the Convert Entities button to pull stuff out of other parts of the sketch. So if you actually select these two faces and you hit check, it'll give you lines now that go the whole length of the cylinder that are basically the projection of those circles on this new sketch plane. So with that, you want to make those projections or constructions. You don't want to use those later. But they let you do very nice dimensions to them now, so you can put them wherever you want in the center. You know the dimensions off of them. You can make a full square to get the whole dimension thing and do it the same way you would the whole time before. Hey, look, Ian, there's a lollipop.
What do I do now? Maybe that was.
How big around is your lollipop?
That's not important.
How big around is your lollipop?
I have a lollipop. The area is 47 inches. Perimeter 25 inches. Diameter 7 inches. 8 inches.
You have an 8-inch lollipop?
Yeah, it's like one of those oversized ones.
How big is the handle? How big is the handle?
Okay. I don't know how to find out.
What's the diameter?
Oh, the diameter of the hair is half inch.
The 1/2-inch handle? How deep is your lollipop? Like face to face, of like the big face to the back big face. So like, quick measure again. Right, so your measure, so click one, rotate on, click one of the faces. And then rotate back to
3 inches.
3 inch thick lollipop? Yeah, your lollipop is literally that thick.
It's
But it's
really
not
tasty.
It's a serious
It's
problem.
that thick. It's like a novel. Why do you think that's okay?
Well, I didn't see it
Like, you realize how like a half-inch diameter is like that? Like,
I want like the movie oversized lollipops.
It's a very thick lollipop, man. It's not the most realistic lollipop I've ever seen.
Share it, it's kind of nice.
And he used the stick as a baseball bat. Lollipop is finished. So,
Okay, so like I got this lollipop here. I got like the cool face on the side or whatever, but it doesn't look realistic because there's like gray on the side.
how
So
did
we're
you
making that
do
color.
that? I actually have no idea where you pulled that from, but good job.
How did you do that?
I don't even know. Where she pulled
Actually,
swirly
okay,
tie-dye.
so first I found like an image that was just like, that
So
pattern
she
thing.
went to make
And then-
decals?
okay, so first I found this pattern like online, right? And then I saved it, and then like I just loaded it like into the thing, and then it had me save a new appearance file, and then it worked. So-
There you go.
But wait, so back to my question.
Yeah.
Okay, so how do I like make the edge like just like the color, like just one edge, not the whole part? Like this face.
Oh, right click on it?
That little drop down button next to the appearance.
Yeah.
And so, right, so you have different options. One is face. So you click just on the face.
No, I wanted to do it on the left.
Oh, well, so that's going to do it with the whole foot.
Yeah, that's it.
So, okay, so what are, you want to measure, and what are your dimensions? So like what's reasonable?
So, yeah, if you go to measure again. Okay, so click off somewhere. Click on that flat face there. Rotate to the back and click on the other one. What's that? It's pretty thick though, like it's a reasonable size. It could exist. The same with the 6. So if you just click on the, you can click any, yeah, you can also just click 0.1. Possible. It's less than 1/8 of an inch. It's a, I mean, it's not unheard of that it could be that small. But it's possible dimension. Have you measured yours? Does it seem to be realistic dimensions? Okay. You making it work? Where are you stuck?
Well, like, so I had like the stick and then this, but it was perpendicular to the stick.
Okay.
So like I couldn't flip it, so it's the stick's here and then the stick's here.
Okay. So did you put a hole anywhere in this? I think so. That's probably the best idea. That's probably your best idea. So in the same way that we were doing that hole earlier on like the round pipe, where you do the reference geometry, put one into the corner somewhere and put a hole that's roughly the same diameter as whatever your stick is. And then when you go to mate, you'll just be able to tell it to go right into it, and it'll do it
I
properly.
found out why I said 3 inches because it doesn't actually measure the faces. It measures like this. There's like the points. It's the actual face. No.
Okay, so you want to drop down that little bit more. And you want us to what? Delta Y is 1.45 inches, which is definitely more reasonable. That little button should be there. X, they want your wait.
How did you make it?
It's actually like important.
I showed you.
Let me measure things. much more reasonable now. Far more reasonable. Your half-inch stick was still a little big, but other than that. Yes.
How do you?
Oh, okay.
What's the center though?
What do I do if I do?
So there's a couple different ways. So one, you could measure between these two lines, and then you would plot a section there and divide it by half, right? Basically, so one way. The other way, you would just take the
edges
draw another for construction line.
Scroll down. And now you just attach it to one of these points.
The other one feels like.
Yeah, do you have this drop down that you
The stick with.
Okay.
Here's my stick. And put some on it.
Can't give it up on that one.
Something cool.
Yeah, it's right there.
This guy.
Okay, that's your first reference. The second reference line. Wait, click there and pick the bus. And
This line is
and then you probably
big
want
one in the
to
whole volleyball, right? And this one, you can do those on here.
Okay,
There, where there's like put midpoint. That one goes right this way.
yeah.
That'll always auto center, so no matter what shape you make it work later. That'll auto center.
Do you know how to?
I mean, there kind of is, but what if you would have figured out a way to mate it, and then you could cut out the mate, but
Get it out.
but it doesn't exist. But I normally wouldn't do that, especially not for something as small. He's talking about the increase especially. Where's your light bulb, Steve? Oh, I had Oh, well, that's not necessary. The reason that is an option for how to do it. Or I guess that is one way to do it. So you need to make a new reference plane somewhere in the middle of like the light bulb, like dead center. Then you're going to need to use the revolve cut and cut out the other bits of it. Over there. Yeah, you decide to get there. No, it is. It's good. I mean, it'll be more visible. Yes. No problem.
Like,
What are you trying to do? Okay, so the easiest thing I can tell you is not to make your stick and your lollipop the same part. To make them in an assembly and put them together. Because namely, your lollipop and your stick aren't going to be made of the same thing. So in general, in SolidWorks, you always want to, whatever, especially when you're switching materials, but more than just if you're switching materials, depending on how it's actually manufactured, is how you want to build it in SolidWorks. So it's going to be built, it's going to be manufactured by taking a piece of candy and shoving a paper stick in it. You need to have two different parts that actually do that. That goes for, especially when tomorrow we'll get into like bolt holes and stuff with real parts. You want to make sure you're actually mating things to their bolt holes like you actually bolt them in real life. The other thing just goes to show everybody.
Only if it
Stop it!
Why are you putting my face on lollipop? Why is it a reasonable thing to do? And of all the pictures too, one of those worst take photos of this one. So wait, let me don't do that. No, I'm fake after this. They're not the Afro bucks.
You have to hold that handle.
It wasn't in my mouth.
At the time it was.
I have not licked the handle. It's really gross. I have not licked the handle.
Alex, you got to do things unconsciously.
You have not licked the handle. We have video of this. Look at that. Look at the replay.
At least, like, over there. Oh, it's there. Okay.
That's better. Wow. Strange pictures, really, Sarah. I get more lollipops? Cool. They look like lollipops.
Understand why SolidWorks is
Why SolidWorks? Right. So you told me.
Okay, so what I wanted to do is be like perpendicular to, you know, the line going out there on the circle, right? And then I wanted to be parallel to this right plane. So I don't think it's like a problem.
I was there when I was trying to do it. So I just did this. I'm so sorry. The talent.
Because you have an edge, it's bad. So, because it's defined, it only defines it in 2 dimensions, right? So you don't get something else to be parallel to. So you would need a third point of reference. So the easiest thing to probably do would be to quickly suppress your fillets. Use that face that you had, just the round one. But then I'll have to show you
Alright, well,
how
I'll
would I
try
do
something
that.
else.
Oh, the other way to do it is just to sketch right on the top plane.
Or
So
I,
you can just sketch right on any of those planes, and it'll still do the cut just for you. Like if you want to cut the whole. Oh, I was saying if you want to start a sketch on any of those planes that are outside of it and perpendicular to it, you can just drill the hole all the way up from there. So you can just sketch on the top plane. You can put a new hole right on it. What time is it? 7:05. Okay, we have about an hour. Yes. If you finish your lollipop, keep playing around, find the next task based on where people are. That is not what we're teaching in. Yay! Reasonable size lollipops. For reasonable size people. what we have. Nope, not there yet. Okay. What have we got? I don't know. Things are freaking out. Okay, do most people have some idea of how they would make their lollipop if they haven't finished, for the people who are making or trying to make more detailed lollipops? I want to see if we can get through a few other things. Let me see where we're at. What's up?
Is there a way to hide the shadows?
Um,
Like the cat shadows?
yeah, so over here, in the farthest right button in your view settings, there should be one that says, there should be one that's pressed that says shadows.
Awesome. Now I have a lollipop floating in my kitchen.
There you
There's
go.
no awkward shadow space.
Mass properties. Sheet metal on Friday.
I can show you how to put it in the kitchen if you want. Okay. So you go to my example. Yeah, that one would drop down menu, and then there's like kitchen one. Yeah, it's in the kitchen, just like mine is. Only yours is kind of sideways very often.
Okay.
You might want to get rid of the shadow too. It's kind of scary to have a random shadow. It looks cool. I like your lollipop too. It also looks good.
What's that tomorrow? Well, what's another? Okay, we're gonna get. All right, guys, let's look back up at the screens. I'm gonna go into a couple more things that we didn't talk about that are a little bit more advanced, and on occasion we have use for. So let's see what we can do. How do I want to do that? Okay, so one of the things we have is what we call a sweep. So sometimes there's parts that would be pretty impossible to build just by the revolve and the extrude that we've learned so far.
Like a person?
Like a prism?
Person.
Person. Okay. SolidWorks is not going to be the best for a person. Like the animation software are better than that. You can do things kind of like that, but it's not the best for that. But more things like a coiled spring would be tricky. There's lots of things that would be tricky to make in just what we've done so far. But for a couple of them, you can get by with another pretty useful feature, which is called the swept boss or swept base. So to actually do that, you have to have two different sketches. So one of them will we'll go ahead and make some sort of weird spline. We'll come out, we'll draw something a little strange. And then if that was on the front plane, on the right plane, on a different plane, we're going to exit that sketch. On the right plane, we're going to make a new sketch. So now we're perpendicular to the sketch we were just at. And we can make a circle that shares an endpoint with that sketch. So now we have something that kind of looks like it's 3D, but it's not yet. And we can exit sketch. We can come in and we can do a swept boss. So it shows these two little profile things. It shows the profile and it shows the path. So we're going to tell it to take this round thing, and we're going to tell it to put it on this path. And now it's mad at me because I made my circle too big for the curvature that I made it for, because I didn't actually think about it. Yeah, I have to make this smaller anyway. Okay. So you have to be completely out of the sketches. So you have to have one sketch that's on, so like in this case, this sketch is on the front plane, and this sketch is on the right plane. And they have to share an endpoint. So when you do it, they'll both, like, you'll start one from the origin or something like that. And then when you do the swept boss base, you can select the profile, you can select the path, and if it's small enough and you have the curves right, it'll actually work. So now we get this cool, like, wire type thing that would be pretty annoying to try to build any other way. So this isn't used all that often, but when you do end up needing it, it's very useful to know it exists. I don't think I've had to use it on a robot too often. There's probably been some, but what? Wayne car spring? That's one way you can do it. There's like a coil feature somewhere. I don't remember where it is off the top of my head right now. But you can like just make a coil, I'm pretty sure. Oh yeah. See, there's this like helix coil feature in. We don't need to go into it because it's weird, but on occasion you do have to use it, and you can make an actual spring. You can tell it how often it goes into. I shouldn't show it to you because I'd have to remember how to use it. Most of the features in SolidWorks that you don't use every day, I basically just go helix, spiral, SolidWorks into Google, and there's some forum or tutorial on SolidWorks, and then I remember how to use it, and then I use it. But more importantly, you just have to know it exists. This will let you draw helixes and spirals. How would you cut what out? You want it. You want it, but you would be able to CAD it. So it would be able to make it look pretty, but you wouldn't be able to really do anything to it.
Can you make a ball?
Oh yeah, some people have already made spheres, but we didn't make a sphere earlier. So a sphere is just the revolve tool that we use to make a cylinder. But instead of using the rectangle to do it, you use a circle. So if we wanted to make an 8-inch ball, we would draw the circle, then we would come in and we would draw a line intersecting it. Then we would use revolve, and we'd get a sphere. Except it's mad because I told it to go 360 with two faces. No, now it's mad for some other reason. Why is it mad? Oh, that would be why. Okay, fine. So most of the time with things like this, you want it to actually be just the half circle. Revolve will be a lot happier that way. So if you come in with trim, you can knock out the, well, sometimes. Okay. Cool. There we go. Now we get a sphere. You don't have to CAD spheres too many times in robots except when making game pieces for the most part. Not often do you have spheres on the robot. It's possible if you had some sort of ball joint or something, you could do it.
Can you do that again? Like when I'm starting from the center.
Sure. So let me go ahead and actually I'll just remove the what we've got. Okay. So we'd start with a circle, and then so then you would draw a center line across that circle. You would use the Trim Entities tool to basically cut out two sides of it, and then when you go to Features and Revolve, you would select this as the axis of rotation, and it'll just automatically do it for you once it knows that you're looking for. Okay. Any other shapes and basic assembly stuff you need to know before tomorrow when we get to real parts? Let me show a few different things in assembly that'll help for tomorrow, that'll make things a little bit easier. Not until Friday. Friday is sheet metal day. And I clicked the wrong button. I want a new assembly. Okay. Alright, so we've only really done a couple different mates so far in the assembly. We've made oh, there's actually a couple other things. So if I want to just place 3 of these cubes, if I click on it once, it's going to go away and only let me place 1. If you hit this little pin up here, that basically means it's going to keep that option open until you force it to cancel. And that lets you place as many cubes as you want over and over again. So that's useful. One of the other things we can start doing is you can start mating a little bit faster. So if you want to always hit this mate button, select the faces you want to mate, that'll work. The other thing you can do is you can click on a face, you can control click on a face, and then when you move your cursor up a little bit, of course it doesn't want to. Oh, whatever. Of course I spoke way too soon as it decided to not bring up the menu that I wanted. Huh. Okay, that's weird. Either way, this still works. So we can mate. So if we make these coincident, it'll make it so the 2 faces are together on the same plane. We can do the same to the 3rd if we want, back to the 1st. And now all 3 are together because you made it through each other. Sometimes you have to do that same type of thing, what I just did where I had to do 2 mates. There's this little paperclip button over here. With like a lightning bolt through it or something. I'm not entirely sure what lightning bolt paperclip the logo means, but it's the multiple mate mode. And what that lets you do is it lets you select 1 to be the reference, then you can select a couple others, and they'll both come up with it. So if you're doing it to a bunch of things, multiple mate helps you get a lot of things mated really quickly. Okay, so now we have a couple things that are all sort of in order. They can't be moved around, but they can be slid right now. So there's a couple other mates that we haven't done. So we basically only mated things coincident and perpendicular, or coincident, tangent, and coincident, and concentric. That's pretty much all we've done. One of the more useful ones, and you'll use a lot, is the distance mate. So you can tell it you want these to be 20 inches apart, and you can select a couple faces, and it'll move them exactly 20 inches apart for you. That'll be really useful in the future. You'll basically, that's how you do a lot of things on the robot, is you'd use distant mates and things like that. Another useful one when you want to center things, so that we know these are 20 inches apart, we could center this block by figuring out the dimensions of this block, subtracting it and dividing it by 2, dividing the other distance by 2, figuring out what the distance between one face and the other would be. Like, you could do the math and figure it out. That'll take a while. SolidWorks can do all that for you. Computers are smarter, way easier to do. And you can actually use advanced mates. So there's a button down here called advanced mates. One of them is the width mate. And with the width mate, you can select a couple different faces. So one is going to be kind of like your bookends, and the other two are going to be the thing you want centered. So you're selecting 4 faces total, and it moves it right into the center. And what's nice about that, since it's not just another distance mate, if I was to come back into here, and I go into the mates folder, in this mates folder you have all the mates that you put on it. If I want to change this one that I had set as 20 inches, and now I want it to be 15 inches, when I move that one, this one, since it's a width mate, will stay centered. So it's really useful in keeping things together. If you know that you want this centered, but you're not sure what the other distance is, width helps with that. We use it a lot for like electronics layout, where we want to make sure that our power distribution board stays in the center of the belly pan, but we don't know what the belly pan width is going to be. We can use that mate to do that really easily. There's a few more in there as well. So if I wanted to place another cube, but this time I wanted it, where's the right plane? So, plane's not visible. Make the plane visible. All right. So this right plane, sometimes also when there's planes, if you want them to be bigger, they come as like a set size based on what the first part was. You can just drag the corners out. So you can make a bigger plane. The plane's technically infinite. It's just really what part of it you're looking at. So feel free. What's up?
I was told to bring my computer because we were going to install CADing software. Is this true?
It was going to happen, and we can still do that. We won't do it today, but we can do it a different day when I actually remember to have it on like a thumb drive or something. But yeah, we can get SolidWorks for everybody. We still have enough licenses from last year to get like 50, and we didn't use anywhere near it. And I'll make sure that Javier or Arthur make sure to get it for you guys this year, so you can re-upload it, because the license from every year expires in December anyway. So like everybody has to reinstall for the new season anyway. But yes, we can get it to you so you guys can play at home or whatever else you want to do. I will say that depending on how fast your laptop is, it is very possible it will be very slow even if it's just a few years old, because SolidWorks is pretty graphics processor intensive. You can make it work, it just won't be nearly as fast as what you're doing on here. Like, these are purpose-built, designed to CAD. Okay, back to what I was showing just a second ago. One of the advanced mates that also is useful in case you don't have 2 whole things you want to put it on, but you just want to put it symmetric to a plane. There's the symmetric mate. So you can select 2 faces of a part, then you can select a plane, and now that'll put that part symmetric across that plane, which is really useful. The other ones, path and linear mate, I don't think I've ever used. Linear coupler, if you want to make cool kind of animation type things, one of our students who did our Frisbee robot had a linear path system that would actually show the Frisbee's path all the way through the robot, and you can have it move other components and things with it, which is really nice, but doesn't really help with building anything all the time. It can, but it's a little bit more complicated than what most people go through. What? Zach. What are we missing? Advanced mates, parts. What else do we need to make? I know, we have 30 minutes. What can we make in 30 minutes?
A wrecking ball.
I mean, you could make a wrecking ball, but I'm pretty sure it would be easy. We don't need to play with spheres too often. You really don't play with spheres very often, SolidWorks. That's not a skill that anyone needs. A what?
A 100%.
A beard?
We got a lot of the little movies.
Let's not try to cat a beard.
Apple. We had glasses.
Shouldn't it be something that doesn't have, like an apple would have like all kind of different curves and
Yeah, an apple would be pretty strange. You can't just really revolve it. No, I'm trying to think if there's any robot part that would be useful.
Let's make our ball an apple.
a wheel.
Let's make our launcher.
And
Your launch.
You could make
Wait,
a barrel
hold
doll.
on.
No, you can't make anything on our. We're not doing sheet metal till Friday, and everything on our robot sheet metal.
What do you think phone block?
a track ball.
Pretty sure a foam block. They literally just cut a circle. Yeah.
They just cut.
They cut a circle out of foam. I don't think they catted that circle.
Well, they probably did cut that circle.
Oh, okay, you're right. They probably did. Oh, actually, with the last 30 minutes, there's a couple things we need to go over. That's not necessarily CAD related. Let me see if I can. No. Give me
They
one.
can hear you this entire time.
Yeah.
So they heard what you said over there.
I don't know. It's possible. Oh, no one's watching this. It's just for archive purposes.
Awesome.
Oops. This might go crazy. Yeah, I don't know what it's about to do. We'll see what happens. Okay. What do I want to show? Okay, so there's a few things. Most of what we're gonna keep doing in here is basically just SolidWorks stuff for the most part. There's going to be some stuff I am going to go over, but one of the things that we have that we put together a while ago is called our recommended reading, which I don't think half of you have read. I know half of you haven't read it.
Yes, I have.
Yeah, you should though.
Remember the programming one?
Because we just did it. Okay. Basically, this has, if you were to go through and read all of this, you would know pretty much everything you ever wanted to know about FRC robots. It's pretty close to complete. Most of this is not stuff that we made, it's just links to other people's stuff. Some of the really good stuff, this link especially, I actually just updated because it had been broken for a while until today. It's actually an MIT course, but it goes through how to actually design stuff. Some of it's a little complicated. There's a few others in here that are kind of the same thing. Because one of the bigger points of SolidWorks is you can learn to hit all the buttons, but until you can actually think about how something's going to be manufactured, design it in CAD, and then have it actually made, that's a much harder thing to actually design a part than just to CAD it. So CADing is the kind of skill thing that's useful. It is useful, but being able to actually design something is what mechanical engineers and people who use CAD for that get paid lots of money and who do it for real, and when you want to get good at robot design and stuff, it's the actual design part, not necessarily just being able to CAD. Like if you can design and all you can do is sketch it on a napkin, you'll be valuable to people, because a lot of people can learn to hit buttons on SolidWorks. Like it is very, very useful to do because it'll make projects and it'll make your robots better, but being able to design is infinitely more valuable. So a couple of these go through different things about how to design. Okay, sure. Thank you, Windows, for freaking out. I know I broke everything. Okay, there we go. So it goes through some things about just fundamental principles of design, things that you can use that'll basically make your design so they don't break. Because like I said, SolidWorks doesn't necessarily know. Like you can make it to where you can kind of test forces on it and things and see if it's going to come close to breaking. But for the most part, especially during build season, you don't really have time to run simulations and things all that often. They do take a little while to get them to the point where they actually are useful. So a lot of your design has to be learning the principles of what will actually work, CADing it, making sure it all fits right, making sure it's actually buildable. A lot of little things that people miss that makes robots really complicated is if you design something where it's impossible to get that bolt in because of how you made it. There's some other face next to it or something, or you can't unscrew something to be able to take a motor out. When you have to go through whole seasons like that, they get really annoying. And we still do it. Like our motors this year are really annoying to take out, actually. We thought they were going to be easy, then they ended up not being easy because we tried to design an easy system. So figuring out little things make things better. So there's a lot of little stuff to think about when you're going through and designing parts in SolidWorks that you can just make all the stuff you're designing. What am I trying to say here? Okay.
You like
Yeah, I know. I lost my train of thought. I've been up since like 4 in the morning. Okay, so back to my original intent. Original intent of this entire statement was the biggest thing as you're CADing, you need to be thinking about the overall design of whatever it is and how it's going to actually be produced in real life. Because yeah, you can make things in CAD and it's great, but it won't help anybody, especially if you try to give the part to somebody else in your team and tell them to make it and they can't. They're going to be very mad at you. So just being able to do basically with what you just learned today in that little bit of time, which didn't seem like much of anything real, you can go in and start making pretty much our entire 2012 robot was basically built with what you learned today. For the most part, it was nothing but, let me see if I can actually open files from that robot. I think I have it. Maybe CAD 2012. What? No. Okay, so most of our 2012 robot was built with things like this, which is an inventor file. Of course it is, because everyone is. Yeah, I think I still did. I finally might have uninstalled it. Wow, apparently I can't even open that file. That's interesting. Okay then. Our 2012 robot was CADed in Inventor and not in SolidWorks. Oh, here we go. Okay, so most of the entire 2012 robot was things like this. We didn't have any sort of outside manufacturing. It was built entirely in basically a school classroom with a drill press and a bandsaw, and that was basically it. So close to the entire robot was this part right here. I think there were 32 of these on that robot, and all this is a piece of 16th aluminum with a hole pattern drilled into it at 90 degree angles. I didn't even put rounded corners on it because they were going to do that manually on a sander. Like, this wasn't a laser cut part. So if I was going to send something like this to a laser, these would all be filleted. But for the manual part, it was just like this. And then we would literally, we had an inkjet printer in the classroom. We would print them out 1-to-1, tape them to a piece of metal, cut them out on the bandsaw, center punch the holes, and drill it all out. And every single one of you can make this part because it's literally just sketching lines to the right dimensions and putting holes there. That's pretty much what the entire 2012 robot was. Well, plus drilling square tube, but numerous times. Something like 1,400 in square tube, but most of those weren't necessary. You could do the same thing with only drilling the holes you actually needed. It would just be a little less valuable. But being able to build gussets like this will make, which seem really trivial, it's far easier than trying to hand draw or hand sketch anything that comes close. We made a few other slightly more complicated ones, if any of those are here. Let's see. So some of them were a little bit more complicated. So these ones had holes for bushings that held the rollers in. And you can see like the hole pattern gets a little weird down here because of the way it mated does things. But again, this is entirely possible. You can CAD an entire robot pretty much with all the parts you would have to custom make. You can custom make with what we did today. Tomorrow we'll go over how to actually do the full assemblies. So we'll start getting into things. Let me see what I can pull up real fast. Couple things, other ways to get better at CAD and get better at design in general is to look through other people's robots. So this is my CAD Others folder that has other people's robots in it. Lots of people post robots from all over the place. Which one of these have a SolidWorks model? Raptor definitely will. Where's Raptor? I don't. That's weird. Guess 2011. Or not. I apparently deleted a bunch of robots that I thought I didn't delete. 2014, 2013. Oh, there we go. We can look at 1114's 2013 robot. They released all their CAD relatively recently. All right. So because this is an imported part, it loses all of its color, so it's hard to kind of see details. But mostly they're a sheet metal team, so a lot of their parts are done in sheet metal. So on Friday we'll talk about how we can learn to bend parts like this, where you have where you get the big hole patterns and you put the little flanges on it and you get these bends. It's actually really simple. So most of what they did in this part was actually just sketched out the part and then cut all the holes. Tomorrow we'll go through and how to add in things like the CAD for motors and stuff. So one of the nice things about FRC is all of that is already given to you. The manufacturers have CAD for their motors, they have CAD for sprockets and pulleys and all of that. So we end up with you end up with a nice large database that teams can build. I can give you a copy of the one we use. If you're on Spectrum, it's all on Drive, so we just pull it from there. But yeah, so all of this is parts that we, let's see, these are all different people's stuff. Where's our COTS folder? So this is all stuff that comes from like Andy Mark and VexPro and all of their websites and the kit of parts. So we'll go through tomorrow and we'll have some of these for people we'll basically start mating these together and make actual sub-assemblies of the robot. But just looking at like VexPro, you can pull their different drives, their different gearboxes, wheels, everything is already done for you. So all the stuff that you don't have to make in your shop, you don't actually have to CAD directly. You'll be able to use right in the assembly, and it's just a matter of making sure it all fits and works properly. Do they do anything that's not sheet metal? I think they're almost entirely sheet metal too. But you can see they go even as far as like they CAD their belts, or that's a model of chain because they're running sprockets here. You could make real chain, but it's not. So there's an efficiency, right? There's no real reason to make it look good if you know that it's taking up the right space. So they do this to make sure the chain path doesn't hit anything. So they have this bar in here for support. They want to make sure the chain path's never going to hit that. So they CAD the actual chain path. So there's a lot of things just getting clearance and things like that as well. If you notice that they don't CAD every single rivet, they don't CAD every single bolt. Because as long as the holes line up and you know the bolt head's going to be there, you don't need to CAD every single thing like that. It would just take far too long. Some of them they do because these were COTS parts, so these come right from Vex with the bolts all the way in it. COTS is commercial off the shelf. Yeah.
Can you like move those parts around?
Can you move the parts around? So because when they release them as step files, which is a format that any CAD package can open. So like Inventor can open it, everybody can. It loses those properties. So it actually loses all of the mates. So it keeps position, but it doesn't have any mates. So normally when you import somebody's robot, you end up just fixing everything and not moving it around. When you build your own and you build it all in SolidWorks, you can do things which I can kind of go through. Let me pull up. Let me see. Where did there we go. So instead of back in this little cube thing, we had a distance mate here. If we wanted to have more flexibility, we could have a advanced distance mate, which says these blocks are allowed to be between 0 and 15 inches apart. Now when you do that, I'm able to drag, and you actually see the movement, and it won't let them go past 0, it won't let them go past 15. And you can do that with different sub-assemblies and things. So like in 2013 we had the lift on our robot, and it was built to where you could drag it in CAD, and you could drag it up and down, and you could see the differences on it and things. Because we really needed to see clearance all the way up through the motion to see if anything was going to hit it and things like that. So yeah, it's relatively easy to get different distances apart from places and things like that.
Can you see like the climbing mechanism for
I mean, you can see it, but again, we can't really move too much around. So their climber was actually relatively simple. All they really did, these hooks telescope out. So by moving this, I'm not going to save it because it's none of the positions are right anymore. Let's see, does this go? Oh, look, it's its own subassembly maybe. Oh no, that's just the claw. So this was their sheet metal claw, or partly sheet metal claw. I'm not entirely sure what they made that out of. It was some sort of black plastic. Might have been thick Delrin. Let's see if we can actually see any bit of it that makes sense. So it's a little tricky to get into because it's not all sub-assembly, but basically that telescoped out. These motors back here pulled basically a winch that pulled it back in, and it was able to pivot up and down. It had pneumatic cylinders that moved the whole thing up and down to bypass the little like knuckle on the pyramid. And their whole chassis underbelly was cut with this V so that it would glide up the pyramid, and it had Delrin along it so it would slide real easily. Okay, other questions from today? What's up?
So why did like the robot lose its color and the materials and everything?
So because when they upload it to the website for everybody to use, they don't know what program they're going to use. So they save it, they export it as a step file. So it's no longer saved as an individual SolidWorks assembly file and SolidWorks parts files. And the step doesn't keep all of that information because the different programs, so like Autodesk Inventor is a different 3D modeling program, has a different way of saving all the color and features and mates and everything. So step just kind of gives you the parts and their locations in space, and that's about it. Some people will upload the entire SolidWorks files. Some people will upload the entire Inventor files if they use them, but not every team does. It's just they're bigger, they're larger, they're harder to do. You could go back in and you could color everything. You could remate everything if you really wanted a working version of 1114's robot in CAD. You could do it, but it would be pretty complicated.
What does the rebuild button do?
So the mates in an assembly will get lost sometimes, and it won't know where things are. So when you hit rebuild or Control B or the little flashlight thing, it'll resolve all the mates. So it has to actually, so in the one where we have like the box, okay, so in this one, so it's having to actually do math to solve where this is for the center. And to be able to do that, it has to do the rebuild. So if I rebuild, right now everything's fine because it's a relatively small thing. But on occasion you'll have, it happens a lot when you do like electronics layout, when you start getting tons and tons of mates and it can't basically keep up with solving. I'll move a hole and there'll be a talon over on the left somewhere that's no longer at that hole even though it's mated to it. You hit rebuild and it'll move everything back over. And it'll resolve all the mates and make things right. So on occasion if you start getting errors from mates being inaccurate or you delete something, hitting Control B will fix that, or hitting the the red green light thing. I don't know why it's a red and green light. I don't know what that means or why they thought that symbol was reasonable, because red and green means nothing. So it means the light's busted and it's a four-way stop now. But apparently. Okay, other questions before we mostly wrap up? Anything people want to see, do? Playing VC. We got most of the way through. I think we got pretty much all the way through sketching and basic assembly stuff. We'll do a lot more in assembly tomorrow. We'll start actually assembling gearboxes and all sorts of COTS parts and how to import and download COTS parts. Thursday we'll play more with that, and we'll probably do some actual robot functions, not out of sheet metal, but of normal stuff. What? What day is it today? If tomorrow we're going to do something and then Thursday we're going to do something, what day is it today?
Sunday.
Monday. Pretty good on this album. Pretty good.
Not too many people are better than you. Only like, I don't know, 7 billion.
That hurts.
That means you're better than at least like a couple million. It's a lot of people. Most of them are pretty young. You're probably better than like my nephew. He's like 8 months.
Come on now, act cards.
We're not playing VC. What other? We have 15 more minutes to answer CAD questions. What questions have you always wanted to know about CAD? Question.
How different is this from Inventor?
How different is this from Inventor? Odds that I uninstalled Inventor, pretty high.
Joe, which one's better for me?
Oh my god, I didn't install Inventor. Does it still run? It's 2012. It's probably not going to run when SolidWorks is open.
Like if I, like, because DiscoBots uses Inventor, so is it like...
DiscoBots switches. DiscoBots never decides. I would be surprised if they don't switch again next year. We used SolidWorks in 2011 because Chris Liccato and I did most of the robot, and they did SolidWorks I think again in 2012. 12 days remaining? Really? That's ridiculous.
Only 12 hours.
This doesn't make any sense. It was in 2012. I haven't installed this in so long. There's zero chance of 12 days remaining. Whatever. You can see the interface. It's a little bit different. It's not much different. Buttons are in different places. If you get the idea, if you know that you sketch and then you go into a feature, that kind of thing. And this has been updated. This is this is 2 years out of date for Inventor, so it looks a little old.
So it's pretty similar.
It is very, very similar. So you open a standard part. We make a part file. Oops. Broke everything. Okay. So we can make a rectangle. It also does a 2-point rectangle. Then if I can tell it to finish sketch, so it doesn't have like the nice little tabs and everything that it does before, but they have the tabs that are just up top. Then I can extrude the same way I would before. I now have a new circle. So all of that's the same. Somewhat annoyingly, the middle click button instead of rotate pans, and you have to shift middle click to rotate. So that was probably that was the most annoying thing when I moved from Inventor to SolidWorks. Was figuring out where that went. But for the most part, all the same stuff is here. It has this weird or slightly weird rotary menu thing. It's not rotary.
It's not rotary.
Right. It has a little up-down menu that you can click little buttons, but this one's like rotary. So the idea behind Inventor is that you can do things really fast if you know where everything is, because you can right-click and then immediately move and just click. Like you don't have to look at the menu if you got really good. And like I could do that with New Sketch back when I was good, but I didn't know most of them. So again, most everything's the same. We can draw things. We can finish sketches. We can in here, so instead of having a separate button for extrude cut, you just use extrude, and then you tell it you're going to cut. And then you select the face, and then it works. So it's a little bit different. Like I said, buttons in different places. But if you do one and you do the other, it won't be too big of a learning curve going back and forth. I'm trying to think. I did Inventor all the way up till right around 2011 when we did the DiscoBots robot in 2011. I learned SolidWorks basically that build season, maybe right before, but pretty much that build season. Then in 2012 I switched right back to Inventor because that's what we had. And then we switched to SolidWorks again in 2013. So back and forth is not too complicated. You do have to relearn buttons. Using the search thing helps. Not knowing which way to rotate gets really annoying. This is my favorite feature of Inventor that SolidWorks doesn't have, and it drove me crazy because I really want it, because you can just like very quickly pick where you want to view things from. Like SolidWorks, if you hit the space bar, you get pretty close in SolidWorks, but you have to hit the space bar and do stuff. Yeah, that is useful. It has this weird thing that I don't ever use, but exists. I don't really know. I think that's about the major differences. Other questions? Nothing? Nobody? Happy? Good? SolidWorks is awesome. We can CAD now. Yay.
You got cards?
Oh no, I broke it. I broke it. Spectrum logo.
Can we CAD cards?
No.
What?
You could CAD all 52 cards if you really wanted to. It'd be pretty easy. All you do is save as and then change the decal, but
And then assembly.
then make a lot of
Oh,
assembly.
and more.
Yeah, there you go. You could CAD a deck of cards. It is possible.
So what are you gonna do?
No one has any other questions? Anything? What is your question?
What was the first CAD program and when?
How do I know that?
Ellen, you're smart.
I
You
am
know
not.
this. Come on.
Things I am not a CAD user, not CAD historian. I mean, for the most people, the really popular one was AutoCAD, but it was all 2D. So when we moved to 3D stuff, SolidWorks came along at some point. I think it was later. AutoCAD had Autodesk Inventor. PTC made a thing called Pro-E that's now called Creo that a lot of people use. It has a kind of command line based thing. So if you're really good at Creo, you can do things really, really fast. But if you're not really good at Creo, it's like I tried to use it once and I was like, I don't know where anything is. It's not that one was a much harder transition because it's not just like a button change. There are things that are actually in just completely different places, and things happen differently in Creo than SolidWorks. But people use it. NASA uses it a lot. But I wouldn't know the first actual CAD program. I imagine that was really, really early. Yeah, it was probably extremely early. Let's see. It'll probably be on the Wikipedia page. Apparently in the 70s, blah, 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 blah. Doesn't really say the first one. Yeah, I definitely don't know. Yeah, if people need to leave, don't think you have to stay to 8. We're done. You can stay. We're not kicking you out. But what? Stop playing cards. Do CAD. Oh, also, when you do leave, please log out of your computers and log out of any computer next to you that wasn't logged into or logged out of or anything.
We have to delete our things.
1981, the solid modeling program Romulus became invented, apparently. That was the first real solid modeling program like we use SolidWorks for.
We have to delete this stuff.
Mm-mm. No, you can leave it there. It should be on your computer tomorrow when we're done. Yeah, if you want your stuff, though, please bring a thumb drive or email it to yourself at some point, or Google Drive or something. Any robot questions in general?
How good does my computer need to be to run software?
It depends on how patient you are. And how much you're willing to close other things. Eventually, at the end of this, because I'm not going to lead you into most of what Adam talks about, but there's a really good YouTube series called Ramp that Adam Hurd from 973 does. He does awesome things like real robot stuff completely, like how to CAD a full West Coast Drive or like this full elevator and things and gearboxes. We'll get you to the point where this stuff makes sense, and then you can walk through and watch his stuff if you want to get really advanced into mechanical design and FRC.